So hello everyone and welcome back. This is day 2 of our Agentic AI Mastery Bootcamp. And today we're going to get into the actual hands-on labs. So quick note before you start, if you haven't watched day 1 yet, please do so. There's a link in the description below. And day 1 just covers all of the foundations, like what Agentic AI is, the core concepts that you need to know before all of these labs. Now in today's session, we're going to learn how to set up and compare 4 different AI providers. We're going to learn how you could extract the clean structured data from the customer messages and how you could build a system that stays up even when a provider goes down. So let's get into it. So this is lab 1, which is multi-provider LLM setup and structured outputs. The big idea here is that instead of relying on just one AI model, we're going to set up 4. OpenAI, Anthropic, Gemini, and Grok. We're going to compare them side by side so you know exactly which one to pick and when. The scenario we're working on is with a retail banking team that needs to choose an AI provider for their customer support system. So before committing to any vendor or whatsoever, we want to compare all 4 on response quality, on speed, and cost. And that's exactly what we're doing in these 5 steps you see right here. Installing and configuring, running them side by side, understanding the difference between temperature and reasoning, and how we could extract structured outputs, and how we could build a production fallback. So by the end of this lab, you'll know how you could securely configure API keys for all 4 providers. You will know how you could run side-by-side comparisons, how you could understand the difference between temperature and reasoning effort, and how you could clear up everything. So let's talk about the 4 providers. Now, each one of these providers are good at something. OpenAI, as you know, is the industry standard. It has GPT 4.1 mini for standard tasks. It has GPT 5 mini for deep reasoning. We have Anthropic as well, which is safety focused for the most part with strong reasoning. Some of the models that it provides is Claude Haiku 4.5. Google Gemini is the cheapest option, by the way. The model we are using is called Gemini 2.5 Flash, and it is built for high volume work. Now, Grok, which is the fastest, not to be confused by Grok, this is an open source platform and it runs the Llama 3.370B model, that too on custom hardware. We're going to get more into that in the later section of this video, but what you're going to do is experience all 4 of them hands-on in this lab. Now, before we write any code whatsoever, we need to set up our lab environment. We're going to be using Google Colab. As you already know, it's free and it runs in your browser with no installation needed whatsoever. It also has a built-in secrets manager, so your API keys are never really exposed in code. So before continuing, make sure to have a Google account and just open colab.research.google.com. Now, if you're entirely new to Colab, make sure to watch this video that is going to be played now. So you probably heard of this thing called Google Colab, especially if you dipped your toes into Python, machine learning, AI, or any one of the super cool sounding buzzwords like generative AI. But what is it really? So we'll start off with the basics. Google Colab, which is short for Google Collaboratory, is basically a free online tool by Google that lets you write and run Python code right in your browser. You can think of this as Google Docs, but instead of writing essays, you'll be writing code. And the plus point is that you don't have to install anything. You don't need a fancy laptop. You just need a browser and a Google account. That is it. No downloads, no headache, just code. Simple, right? I'm going to show you how you could access it. In a new browser tab, even if you just type Colab and Google or Google Colab, it doesn't matter. You just have to click on the first link that pops up. This will take you to the main Google Colab homepage. And from here, either you could open Colab directly or you just click on New Notebook. Both of these things almost do the same thing, so it doesn't matter. Let me just cut the previous tabs for now. This will bring you to the main menu page. And before you do anything, you just need a Google account, so you could just sign in. I'm just going to input my details and click on next. And this will automatically log me in. And this whole menu will pop up where you could check out all of the recent Python notebooks you have. You could check out the GitHub repository as well. You could connect it. You could upload any other Python notebook you have directly from your local device. And we have examples over here as well. If you're new to Colab, these are all of the things that you could check out to get familiar with the whole service. Right now, I'm just going to click on cancel and show you what all of the things in the main menu looks like. So before we dive into what Google Colab is, let's just take a quick look at the layout. You will see this once you open a Google Colab notebook. And this is important because if you are brand new, this interface can seem a bit overwhelming. But it is actually really simple once you know what's what. So first we have the top menu bar you see right here. This is the menu where all of the options live. You have the file from where you could create a notebook. You could open existing ones. You could save your notebook as well, or download the notebook that you have just created. You could either download the Python notebook or directly a Python file from the code that you have written. You can also directly copy this to your Google Drive if needed. Next, we have the edit section. This is where you could cut, copy, delete, or undo any of the changes to the cells that you have. These will be coding cells that you will be working with, and this is basically an editing option that you need. From view, it will show you all of the line numbers. And from here, you can open the table of contents sidebar, which you see right here. And if you need notebook information, or if you want to see all of the code that you have executed previously, or if you want to check out the comments as well, if you want to hide them, expand them, or minimize them, you could do so from this option. We have an insert menu as well, where you could add a new cell or a text cell. You'll be using this a lot. We have a runtime. This is where you can connect to the cloud hardware. So you could either use a GPU, CPU, or a TPU. So you can change the runtime type from here. You could change it to Python, R, or Julia. You can choose any of the hardware that you want. The fastest one is a TPU, which is a tensor processing unit, which is exclusive to Google. You could use a GPU as well, but the default one is CPU, in case this is the first time that you're using it. And do note, all of these processing units you see right here are for free. And if you want to use the advanced versions, you could purchase them directly from Google. So that's how you could change your runtime. We also have the tools section where you could access the user preferences and the experimental features. But you won't be using this a lot until you become a professional Google Colab user. And the help section is just a link for the documentations, keyboard shortcuts, and the feedback options you have. Then directly on the right, you see you have a connect button over here. This button connects your notebook to a virtual machine, essentially a remote computer which is hosted by Google. When it says connected, it means you'll be ready to run code. You can also check out your RAM and disk usage from here, and you could switch the hardware types as well. As you mentioned earlier, CPU, GPU, or TPU. So let me show you how you could create a notebook from scratch. So click on File, and then click on New Notebook in Drive. Once you click on that, a new tab will open up where you could check out the entirely new Python notebook that will be created for you in Google Colab. You could change the name from here. I'll be keeping the name of the Python notebook as what we'll be doing today, which will be a simple linear regression. So that is the name I will choose. And once you have a Python notebook, you'll see all of the toolbar buttons over here. So this play button means it'll run the current cell that you have. Then if you hover in the middle of the cell, you'll find a code button and a text button. The code button just adds a new code cell if you click on it. And the text button just adds a note if you want to type anything. It could be details about any of the codes that you are running, or it could be anything if you want the reader of your Python notebook to get more context about what you're trying to do. You could add images, you could add graphs, any sort of data that you want can be added over here. You also have the left sidebar panel, and you could access it by clicking on this. This will be the table of contents. It automatically tracks all of the headers, so you could jump between sections in case you add a section over here. In case you do add headers over here by clicking on this button, like a new section will be mentioned and will be updated over here as well. So you could add more sections and you could individually move to those sections by clicking on it. For now, I'm just going to delete it as I don't need it. You have a find and replace section as well, which you'll be using later on once you have a lot of code. We have a code snippet section where pre-written code for tasks like loading CSV files or displaying charts will be mentioned, which you could use later once you're more well-versed with it. You have a secrets section as well if you want to integrate your own API keys, but these are things which you'll be discussing later on. You have a file section as well where you could upload the local files or you could mount your Google Drive for access. You have a variable section over here too, which just shows all of the current variables in memory and their values as well, which is useful when you want to debug something. You could check out the RAM and disk utilization by clicking on this. You could see the system RAM you have that Google is allocating you and the total disk space as well. And all of these resources are for free, by the way, in case I didn't mention it earlier. We have the Gemini AI assistant as well on the top right corner. This is Google's pre-built AI helper. So you can click on the sparkle icon over here to open it. And from here, you could chat with it. Like it can explain code, fix all of the errors you make, write better and efficient code compared to you, or even answer questions. And this will be done right inside your notebook. So this was an overview of how the whole menu looks like. Now, before Colab existed, coding in Python meant jumping through a bunch of hoops. I'll just show you all of the things that you needed. First, you needed to install Python. Second thing you needed was a code editor. So you needed a tool like Visual Studio Code. And you needed a bunch of libraries too, like the NumPy library and the Pandas library as well. These are only two of the popular ones that people usually use for data analysis and numerical computation. So it was like assembling IKEA furniture, but with no user manual. So Google built Colab to remove all of this drama you see right here. So now you could just open your browser and start coding with zero setup required. Now, if you ever heard of Jupyter Notebooks, you might think that a Colab looks familiar, and that's because Colab is built on top of Jupyter. So yeah, Colab just basically takes Jupyter and throws in free cloud computing with it. So whether you are a total beginner or someone who is just trying to run a quick model, Colab is honestly a no-brainer. As we discussed, there's no installation, you just open and go. There is free GPU and TPU, as we discussed right here. We have a free CPU right here, and you could change the runtime type as well. You could change it to a GPU and a TPU as well. And it is beginner friendly. It doesn't really look that complicated. You have a clean and simple UI. As you know, all of the Google features, so if you liked using Google Docs, Google Sheets, and Google Slides, using Google Colab would be simple as well. And you could share the files easily. All you have to do is click on this button you see right here. You can just click on this. You could choose whoever you want the file to be accessed by. You could keep a restricted access. You could keep it within your organization, or you could simply keep it anyone with the link. And over here as well, if you want people to just view it, comment on it, or become a whole editor, you could change the permissions like that, copy the link and share it with them. It is that simple to share your work. It's basically like showing up to class and finding out that someone already did your whole homework setup for you. You just have to write the answers. All right, now that we explored what Colab is and how its interface works, let's try actually running some code. Don't worry, this isn't going to be some boring Hello World demo. We'll write a tiny Python code snippet that introduces you to the world of AI in the simplest way possible. So I already gave a spoiler. We'll be doing a simple linear regression prediction, something that machine learning models do all the time. So I'm going to show you how that looks like. First, I'm just going to be declaring some variables. So I'm going to be keeping x as 5, keeping a variable m as 2, and a variable b as 3. Then at the end, y will be the variable, which will be the predicted value at the end. So I'm going to keep that as m. And you could see Google has automatically added what I'm going to type, which is really cool. This was what I was going to do eventually. And at the end, I'm just going to print y. So the predicted value of y is, I'm just going to end the print statement by adding a y at the end. Now, before I run this code, let me just break it down to you in simple terms. We are using a basic formula, which is y is equal to mx plus b, which is used in linear regression, which is a basic machine learning algorithm. Here, m is the slope, and we are saying that it is 2. B is the intercept, and we are setting that to 3. And x is the input, and we set that to 5. This tiny formula predicts a value y based on the input x. It's like saying if x is 5, what would y be according to this line? So to run the code, you just have to simply click on this play button you see right here on the left side of the cell. And you could see it didn't even take 1 second. It gave you the predicted value. And if you don't want to click on the play button, you can just simply press Ctrl and Enter to run it again. So you could click on it again and it'll run it for you. So when you hit that play button, Colab connects to a temporary Python runtime in the cloud. So it sends it over there and executes it. And it brings the output right back under the cell. So even if you don't have Python installed on your machine, Google Cloud takes care of that. So that is it. Your first AI-related calculation done in the cloud without installing a single thing. Pretty neat, right? This is how you'll be running your future Python code in Colab. You just have to type in your logic and hit run and boom. The cloud handles the rest. So you can do a lot with Colab in general. You could learn Python from scratch. You could run small machine learning projects. You could build generative apps using OpenAI or even Hugging Face. And you can practice data analysis with pandas or math.lib. And the best part is you don't even have to install all of these libraries. Most of the libraries that exist are pre-installed in Google Colab. So I would like to end with a note like, who shouldn't use Colab? Since you all are learning how Python works and how a genetic AI and everything works, you are not really working with sensitive or confidential data. So it's okay to use Colab as long as you're not doing that. So if you are working with sensitive or confidential data, if you need long runtimes without disconnection, and if you're training very large models, like Colab has RAM limits, or if you need complete control over your entire environment, in that case, it's better to go for a local tool like Jupyter, VS Code, or a cloud virtual machine on Azure or AWS. But those are the only reasons when you shouldn't use a Colab if you have sensitive information. So there you have it. Google Colab is your launchpad into the world of coding, AI, and machine learning. And the best part is it's free, fast, and ridiculously easy to use. So don't wait for the perfect setup. Just open Colab and start writing code. You will learn faster, build cooler stuff, and honestly, you look like a tech wizard in front of your friends as well. I hope you found this video informative and I appreciate you watching it. With this, I would like to conclude the whole video and happy coding. So welcome back. Up next, if I already didn't tell you, the URL that you need to remember is collab.research.google.com. So make sure to bookmark that. You will be using it throughout the entirety of day 2. Moving ahead, we have a whole Python cheat sheet. This slide is reference for the basic Python patterns that you'll be seeing throughout the whole notebook. All of the imports, variables, dictionaries, loops, and functions. So make sure to keep this handy, or you can just take a screenshot of this because we'll be using it throughout the lab. Now next is step 1, which is installing the SDKs. SDK, if you don't know, is a software development kit, and one single command, as you could see right here. This just means it's going to install all of these model SDKs that we can work with. So make sure to run this at the start of your Colab session and you'll be ready to go. This is what we're going to discuss in the video as well. Now in this video, we're going to discuss what an API key is. An API key, as you know, is a password for a provider service. We're going to get into more detail in the lab, but before we proceed, you need these 4 API keys. For OpenAI, you need to head over to this URL, which is platform.openai.com. For Anthropic, you need to head over to this URL, which is console.anthropic.com. For Gemini, it's aistudio.google.com. And for Grok, it's console.grok.com. We have a dedicated video for each one. So make sure to watch all of these now and make sure to just create your keys before you can move forward. Now, if we begin with OpenAI, this gives us the GPT 4.1 mini model, which is for standard tasks, and we'll also have GPT 5 mini for deep reasoning. So make sure you watch this video right now.
Hey there, this is Atul from Team K29 Academy, and in this video, I'm going to talk about how to create an API, which is an application programming interface key for accessing an LLM, which is a large language model. And in this case, we are going to look at a large language model from OpenAI that created a ChatGPT. So if you want to use any LLMs from OpenAI, how to do that. We also have already another lab on if you're creating an LLM from Gemini, which is from Google, how to do. Now, if I want to understand and explain you the terminology and concepts from here, API, as name suggests, application programming interface, you make a call, whatever request call from, it could be from a command line, it could be from another program, it could be some way to access LLMs programmatically. You do it using that API. Think of it like a user ID and password securely, so that, and you can grant permissions, etc. We will look at that. So if I say, so think of it as a token which I'll be giving and I have access to. That's what is API key is. So later we're going to see how to use them, but assume for the time being that you're going to use. Later we're going to do some labs about agentic AI, generative AI, AI machine learning on AWS, Azure Cloud, and that if you're using appropriate model, this is when we are going to use these API keys. And the steps are very quite simple and easy to follow. So what you're going to do is you're going to open this key or this document here, and that's what you're going to follow. This document will explain as well if you need any other thing, but it's quite self-explanatory. So first and most important is that you're going to go to this URL, platform.openai.com. This is where you're going to go. And by default, I think I've already logged in, so let me log out from this so you can understand, assuming you don't have any account. You can, so let me close this one more time, and you're going to go to this platform.openai.com, and this is where you're going to access this URL. So first thing you're going to go is, if you already have an account in ChatGPT, you can use your Google account, use that. If not, you simply say sign up here. In this case, I'm going to say continue with Google. You can either create a user ID and password, or you can do single sign-on using either Google or Microsoft or a Apple account. I already have a Google, so I'm going to use this Google account. on here, and then I'm going to log in from one of the email IDs which I've already have that. Once you do, you will be able to go and create this account on here. So you go under profile here and say your profiles. Under that profile, you will see one second. Uh, API keys. Left hand side, you see API keys. I already have an API key, so I'm going to delete this first so that I can explain you from scratch what you're going to do on here. Now, there are two parts in that API key. First is you're going to create an API key, and later for in future, you'll be some labs are free, some labs you have to, or I would suggest you create an or make an put a billing or your credit card on that. I'll explain you why. If you're doing some agentic AI labs or some advanced labs, it'll need a API key payment plan for do those API keys. Now the payment plan it'll be negligible amount. It's less than couple of cents. But it needs minimum spend. It needs a credit card so that even if in future if you use some of the advanced things in OpenAI, it might can use that credit card as well. So again, I'll explain you the process when it comes, but you don't need to worry about that. So what I'm going to do is I'm going to go and create an API key, which I'll explain you here. It's quite self-explanatory, simple. You simply say create an API key. Now you can have a service account as well, which we'll cover later. For now, you just create and say owned by you, and then see API key, or maybe I'll say OpenAI key, whatever name you want to do. You can put any name of your choice, and you need to be created under project. So we'll use the default project we'll create, and you can restrict, you can read only. I will suggest you do all, and you should be doing all for doing this lab. Later, when we go more advanced, we can see how to get a restricted or read only API keys. So we'll create the API key, and then we'll copy. That's all you need to do. If for some reason, let's suppose you forgot, you can come here and then edit, and this is where you can see um, on this is where you can go and look at this key here from here. Now for some reason, if you forgot to save it, you can create a new one as well. You can create as many keys as you want, and then you can delete as well. So this is where you can go and delete these keys as well, so you can revoke access if you want to. So let's suppose revoked, it's being gone here. I'll create a key one more time here, API key. Make sure you remember to save this in a place. And so create a secret key, and then this is you copy. Make sure you keep it in safe place. You won't be able to review it again. So it's important that you secure and save it. Otherwise, you have to delete it. In case you forgot and you want to retrieve it back, you won't be able to retrieve that. So that's point number one, which is you've created a key right now. This is enough for just this is not enough. You have to further go and also add a credit card. The reason which I'm saying you need to do is later part we're going to use these LLMs, and in that if you don't do that, you will not have access to, you will get an error, some other error, which I'll explain you in a minute what kind of error you get. Yeah, so when you're performing labs, this is later you get a error message, something like this. I'll explain you here, which is you'll get an error message saying that OpenAI model rate a limit error, and it's saying you exceeded your current quota, which means you have to add some billing on this. So how you could add in billing is you click on here billing. On here, I already have a credit card here. So and because I've already added this credit card, so I'll simply say cancel plan, or I don't want to do this. One second. Let me show to you if I have another account, which I'll show it to you another account, so that I don't remove this point because I'm already using some of the APIs in some of the program here. Now this is another account which I've created, just a fresh account. So right now I don't see on here. So probably what I'll do is I'll say start building, and this is where I'm going to put a name and say dummy name or my dummy org, whatever name you want to do, and what describe somewhere technical, non-technical, maybe somewhere technical, but create an organization. This is a different email ID which I've used, and I don't want my team members later. And this is where I'm going to create my first API key and say generate API key. So this is maybe your first time if you have a fresh account, just wanted to highlight to you and then copy it. If I go and now look at here, now you see your profile and all the other things that you see if you go first time here. So I'm going to change this API key. This is where I'm assuming you've already created an API key. I'm going to delete, and now rest all is same as you see. So this is also you've seen first time. If you've never created an account fresh, this is how you will see. Now, the main point was about billing. This is where you're going to get, by default, it's a 00. And this is where you're going to say add payment, and you enter your credit card and credit card details. This is what you'll be, this is important. You enter your card details, card number, billing address, and like any other payment plan you're doing, and you can do normal uncheck, keep it depending on whether it's a business card or a normal card, and just provide the details. And then you're going to go on here, minimum $5. Let me add it, and then I'll delete it this point. I'm just showing it by adding it here. Now, so as soon as you get you add the credit card, which I've added, it says initial credit purchase, you just leave it 5, and then you can uncheck that unless you're doing it for pay as you go model and you have to do it. Future $5 are more than enough. If there's anything, we'll let you know. But as I said, you will be charged under a cent dollar, or I've never noticed payment done because I'm using we are only requesting very small APIs, and we are only triggering very small amount of transactions and tokens we are using on OpenAI. So you don't need to worry about this money. It'll be under a couple of cents only. So just 5, and then uncheck here if you're worried automatically deducting, and click on continue, and then say confirm payment. And there's a tax as well because I'm doing 20% VAT in UK. That's why it charges this, and it'll be saved here. So now if you see here, the payment details have been added here. You can always add or delete if you want to delete here. You can go and delete these payment methods here later. Okay, but that's enough for now. Will not be payment method. Okay, you have not started the billing payment yet to a payment plan. It'll come and it'll refresh here. So let me go out and log out from here and log back in from my ID. So this is how it should be. So for example, set as default or delete. So I'm going to delete as soon as you can go and delete here, and that's how you see billing history and overview $5. This is again, yes, yeah. So that's pretty much on creating a key and adding a billing onto this. So I can go back, open API key, and then again, this is the key which you've done.
After you have the API key for OpenAI, what you need next is the API key for Google. Now, Gemini, as you know, it gives us Gemini 2.5 Flash, which is fast and cost effective. So make sure to watch this video right now to know how you could get one for yourself.
In this video, we're going to look at how to create an API keys so that in future, when we are going to access the LLMs, which are large language models, how do we access them securely through this API key? Now, everything that you need to know about this particular lab will be visible or in this page. Now, there are some concepts which I'm going to cover about what is an API if you're a complete beginner, not a developer. I would still want you to, if you're not a developer, still want to understand these concepts, or whether you're architect, administrator, it'll help you to understand. You may not be developing the code, but understanding is important for you, whether in, as I said, whatever role you play, this concept as well. And so here we have explained some concepts. Now, the API keys we are going to create are for different LLM provider. What is an LLM? You can read out. I'm not going to repeat that again here, but you can click on this. What is a large language model, which is we have covered. You should have a basic understanding of what is foundation model and then LLMs. We'll be primarily working on LLMs, large language model, which is covered here in this link on what an LLM is. So there are multiple LLMs we'll be working. In this particular case, I'm talking about Gemini from Google, but you can have from Hugging Face, you can have a Llama from Facebook and so on. But what these large language models are and some of the providers that you'll be working in, that depending on which program you're watching this, you will have access to. For example, we'll be using GPT from OpenAI, Hugging Face, or Claude or Llama by Facebook, Meta, Gemini. In this case, I'm doing. So what exactly is an API? Application programming interface, a way to communicate to other software program. In this case, I want to communicate with Google's Gemini on this particular lab. And then you can read if you want to go further here. And we are going to create a key, which means think of it as like a user ID and password. But in a simple terms, I'm talking about, you can further read it down. I want to keep it simple and straightforward so that you can access the models, or the agent that you're going to create can access the model or access that Gemini model from Google, or in future Hugging Face and so on. You need to create this lab only once, or perform this lab once, and use the same keys again and again. So what you need to do is, if you look at the documentation, this also has a little bit more documentation about what you need to read about what is an API keys. If you're a developer, you probably already know. If you're not, this is more for architects, administrators, and system administrators and so on. So we are going to access. There are, as I said, there are model providers. Have a read at that as well. And the documentation link. So we are using, in this particular lab, we are using Google Gemini, or Gemini from Google. But then again, as I said, you're going to use for other, in future, you'll have similar concept for OpenAI, accessing the OpenAI and so on. Now, there's no prerequisite. Oh, there's a prerequisite. You should have a Google account, which I'm assuming you already have. But if not, creating a simple Gmail account should be enough to create this. There's no costing, there's no pricing, there's no charge for this particular lab. So what you're going to do is you're going to go to the Google AI Studio, which is aistudio.google.com. So let's copy this. I want to go to the incognito mode. So copy link address so that I completely go from blank new incognito mode. And then you say type this aistudio.google.com. Now I've already logged on. I'm not sure why. So sign out. And then let's assume I'm looking, first time I'm going into this, I'll say Google Gemini pricing, scroll down somewhere and sign into Google AI Studio. And for the type of work we are going, this is more than enough. I've already, now once you have logged in, you will see a screen like this, which is a Google AI Studio. And again, if you're part of Google training, we will be covering in Vertex AI and a lot of Google AI Studio, the difference between Google Vertex AI and Google AI, both of them. But Google what AI Studio is enough. Click on Get AI Access Key. Now create an API key. Now I'm going to delete this key. So you so please don't copy, even if I showed to you, don't do that. Don't do basically, don't copy paste or use that because it will not be used for you. Now I've already created a project on here, so you can create a project. So everything in Google Cloud or Google is based on a project, and then other things, if you're part of Google Cloud, our Google Cloud, that's when you'll learn and understand. But think of it as like a project that I'm creating. So I already created a project. If not, you'll be creating your first project. It'll say that first project, and then um, that's where you create, and so your everything in Google Cloud exists within a project. So you either create a new project. If you never created a project, it'll come like, oh, create a new project. Or in this case, I'll say, because I already created a project, I'll say create an API key in the existing project. So let me see. So the screenshot, depending on, you'll be getting and say, oh, create an API key in a new project. You can also create an API key. So I'll say that I'm saying just put a name and then copy paste this key. Now copy paste this copy and then keep it sensitive anytime in securely. As I said, I'm going to delete this key for now immediately after this. So, but in future, if I need, you only need to create it once and then you can reuse it as long as you want to reuse in that particular project or work that you want. That's pretty much, make sure that you keep it safe. That's pretty much you need to do in this. There's no other thing you need to do.
Now, you'll also be needing an API key for Grok, and you know it's an open source model. Llama 3.370B is the model, and this is the fastest of the four. If you want to know how you could get an API key for that, make sure to watch this next video.
In this video, I'm going to talk about how to create an API key, and we're going to use for two different providers. One is LLM from Hugging Face, and second is Grok, or whatever you call Grok from X, or earlier Twitter. And yeah, so how to create those. Now we'll explain what is an API key is. If you're new to this, if you're already familiar with it, just jump on this, just jump on this document and create that API key. Now we are going to use these API keys later. We're going to do some additional LLMs that we will see. Now in this, we are going to, these are the labs that you see. There's other API we have done earlier, how to create an OpenAI key or also Google Gemini. There are other things. We are going to use these API keys later when we go to invoke LLMs in further other programs like Agentic AI and so on. I'll explain you as well what next to be done. Now, simple terms, API is application programming interface to way from a client, which could be you as a machine, you working as a end client or working as a machine system, anything that is making a call to someone else programmatically. That's application programming interface in the simple terms. You can read out this as well on the simple terms, and there are different use cases for API key. Think of it as like a user ID and password, but encapsulated in a key, a big key that you can use to connect and get that permissions as well. Now you can create using Google or GitHub, or you can use your email address as well. I'm going to create a simple using Google, and I'll put my email ID here, and then it asks me the permissions. We'll say yes, grant the permissions to read my name and email address, which is fine. And now I'm on Grok here. So this is a Grok. By default, you're going to land on a create API key. You can also go from here, and you'll be looking at whether it's organization or personal. I'll look at personal, and then I'm going to look at which project. You can create multiple projects. Project is nothing but collection of whatever projects you're running. So leave it to default, and you can click on create API key, or you can come here and you can come do here as well. So I'm going to say display a name and say Agentic AI, and then click on submit here. Again, make sure you copy it now. It will not be displayed again. Same process. I'll copy, and then later I'm going to use that. If I want to delete it. Now I know how to go and create. Very simple, straightforward process.
And finally, the last one left, which is Anthropic. It gives us the Claude Haiku model, which is strong in reasoning and instruction following. If you want to know how you could create an API key for this, make sure to watch this next video right now.
So basically today we are diving into this particular thing. So this is designed for anyone working with or planning to work with the Agentic AI labs, which is basically which are hands-on exercises where you'll actually build and interact with AI system. Okay, so this is basically, you can think of this as your starter kit, the very foundation you need before you can do the exercising stuff. So basically, you can't drive a car without your keys, right? So well, you can't talk to an AI model without your API key. And that's exactly what we are setting up today. Okay, so this lab is described as the prerequisite guide. Okay, so specifically, we are going to walk through the steps needed to generate API keys. Okay, so those spatial access codes that will allow us to authenticate with LLM models. Okay, so here you can see the first thing we need to do is, here we have the link for Anthropic. As you can see, just simply click on this particular link. Click on the link to visit the Anthropic Cloud. You can just simply click on this particular link and visit the Anthropic Cloud. So this is our Anthropic's official platform, the front door to everything cloud related. And think of this as waking up to the entrance of the building. We are about to step inside. Okay, here we have the option. Now at the next step, very next step, we need to log in with the Google account. Okay, so if you have a Google account like a Gmail address, I would recommend clicking on continue with the Google because it's the fastest option. Just select your Google account when prompted and you'll be logged right in. So if you would rather use an email and password as well, click the email sign in option here. As you can see, you can write your email as well and then continue with the email as well. Okay. So once you're logged in, you'll land on your dashboard, okay, with something look like this. As you can see on the home page or dashboard menu, this is my dashboard after the login. Okay, so this is your home base within the Anthropic console. Okay, take a moment to look around. You'll see a clean interface with some navigation options. So this is your control panel. We are going to use it in just a moment. Okay, so basically then we need to check for the API keys here in the manage section. As you can see, if you go to the manage section here we have the API keys option. You can just simply click on API keys. Okay, and here you'll find the API keys. Okay, how to create and all other your API keys as well. Okay, after that we need to click on create API key. Okay, as you can see, these are basically the things. We just need to click on create API key. Simply click on create API key, and here you need to provide a name to your API key. Okay, so as you can see, if you scroll down, you can simply name it anything. Okay, so you can write as my API key or anything you want to add. Just simply click on add, and here you'll get the API key, your API key. Okay, so basically you need to copy and save your API key immediately after this process. Okay, so the moment your key appears on your screen, I need you to do one thing right away: copy it and save it immediately. Okay, so basically, see, Anthropic only show you this key once only. So the moment you close this pop-up or navigate away from this page, the full key is gone from your view forever. It's stored securely on Anthropic servers, but they won't display it to you again for security reasons. Think of it like someone's whispering a secret combination to you once. If you don't write it down immediately, it's gone. Okay, so basically, see, look at your API key on screen. It will be a long string of characters starting with something like anything SKANT followed by a long sequence of letters and members. So that's entire string is your key. So basically here we have the copy key option. As you can see, click on the copy button next to your key and it will third immediately open the notebook on Windows or text edit on Mac or any simple text application. Even opening a Google Doc works perfectly. And paste your key there by pressing any particular button and save the file somewhere safe on your computer. Okay, so basically after this process, after saving the API key with something look like this. Okay, as we have the important note as well. Okay, One more thing I want to highlight from this thing, basically, do not share this key with anyone. Okay, this key is like password to your Anthropic account. If someone else gets it, they can make API calls using your account. And since this is a paid service, that would mean charges appearing on your billing. So keep it safe, keep it private, treat it like your bank PIN. Okay.
And that's it. Once you have all 4 API keys, we could actually move ahead. So now that you have all 4 keys, we're going to store them in Google Colab Secret Manager, not directly in code. We're not going to make that mistake. So what we need to do, as you could see right here, we need to open the key icon in the sidebar. And with each key, we'll have a toggle and notebook access, and we're just going to load them up over there. So this way, your keys never really get committed to the GitHub or even get shared accidentally. Make sure to keep all of this saved. If you want to know how you could do everything in detail, make sure to watch this video that is going to be played now.
So basically here in this particular lab, we are going to learn how to use a spatial secure storage space built right into Google Colab. So think of it like a personal space or personal vault where you can store your sensitive information separately from your actual code. So this way, when you write programs that need to connect to service like OpenAI, Anthropic or Google AI, your secret keys stay hidden and protected. So we'll walk through exactly how to set this up and why it matters so much and how to use it in your everyday coding projects. So by the end, you'll be following one of the most important security practices that professional developers use every single day. Okay, so let's first understand what are secrets. So Colab Secrets is a built-in feature in Google Colab that acts as a digital vault. So basically, Google Secrets allows you to store sensitive information, things like API keys, passwords, access tokens separately from your code. So these values are stored at the account level, which means they live in your Google account, not inside the notebook file that you might share with others. So when you create a notebook and share it with a friend or colleague, the code is shared, but secret stay locked in your personal vault. Your friend can see your code and even run if they have their own secret setup, but they can't see your actual keys. So it's very beautiful system and keeps everyone safe. Okay, why we are doing this? So basically, the first very major thing, very important thing is we want to prevent accidental clicks. So this is the biggest one. Like when you are working on a project, you might share your notebook with a classmate, a co-worker or a community forum to get help or show off what you built. If your API key is hard-coded, meaning it's typed directly into the code, then everyone who sees the notebook can also see your key, even if you delete it later. So if someone saved a copy or took screenshot, they'll still have it. Okay. So one more thing is people also often push their code to GitHub, which is platform for sharing and collaborating on code. Like if you push a notebook with a hard-coded key to GitHub public repository, anyone in the world can find it using simple search tools that specifically look for exposed API keys. So it's very scary, but it's true. Attackers use bots to scan GitHub consistently, looking for exactly this kind of mistake. Okay, that is why we are using this particular thing to prevent the accidental leaks. Then second thing is code. Then second thing is code portability. Like we want code portability. This is fancy term, but it just means that your code can move around easily and work in different places. Like if your keys are sorted separately, you can share the logic of your code, the actual smart stuff you built, without having to go through and clean it to remove your personal credential first. Okay, so by keeping secrets separate, your code is clean and shareable from the start. And the third is security compliance. So in this professional world, storing credentials separately from code isn't just a good idea, it's often required thing. So companies have security policies and many industries have regulations that say you must protect sensitive data this way. So the approach we are learning today is based on something called environment variables, which is standard industry practice for securing software. So whether you are building a mobile application, a website, a data analysis tool, or a machine learning model, this principle applies. So by learning it now, you are not just protecting yourself, you are also learning a skill that will make you better, more professional developer or data scientist. Okay. Okay. Now we are going to actually set up your first secret in Google Colab. Okay. I'll walk you through this step by step. So before that, we have a prerequisite. So let's make sure you are in the right place. So we need to go to Google Colab. You can search Google Colab on your browser and you can open Google Colab, or you can just simply click on this particular link. So you can open up your any web browser, like whatever browser you like, okay, and go to the Google Colab website. You can either type in address directory, or just you can type Google Colab and open Google Colab in your favorite search engine, okay. So make sure you are signed into your Google account. Colab is the Google product, so it uses your regular Google login, the same we use for Gmail or other different products. So if you are not already signed in, okay, follow this particular lab for setup and a user's guide of Google Colab, okay. So let's open Google Colab now. I'll click on this particular link. So here you can see this is our Google Colab. You can open any particular file you need, okay, to store the API keys. So we are in the Google Colab now, okay. As you can see, we have opened the file untitled, okay. Don't worry about renaming it right now. We are just using this as our workspace for this particular exercise, okay. You can upload your file and do this work too, okay. So here on the left hand side of your screen, okay, we have a vertical bar, and these are the features that we have. And what we are looking for is a specific icon, which is this, the key which is the key secrets, as you can see. So when you first click on secrets key, a panel will open like this, okay, showing you the secret interface, okay. If this is your first time here, it might be empty, or you might see some instruction explaining what secrets are. So don't worry if it looks a little unfamiliar, okay. So I have stored my secrets keys here, as you can see. If you open this particular thing first time, okay, it might be empty, okay. Now here you can see a button that we have, add new secrets. So click on this particular button to add secrets key. Now we have two particular things to add. Here you can see name and value, okay. And this is where you are going to create your first secret, okay. So the first field, the name field, this is where you enter an environment variable name. Environment variable is like a label on the jar, okay. So this is where you write that label. The name you put here is what your code will look for when it needs to access the secret, okay. For example, let's say we are securing, so let's say we are securely storing an OpenAI API key, okay. So here you can see this is my label for that particular thing, okay. This is my environment variable name, like OpenAI API key. Like that only we are going to save another key here, okay. So here you can see you can paste like this also, okay. This is my OpenAI API key, that is my environment variable, okay. Here you can see we are basically using all capital letters and underscores instead of spaces. So this is a common convention in programming. It makes the variable name clear and easy to recognize, okay. So you'll see this particular pattern a lot in code, so it's good to get used to it, okay. And here you can put down your value of your OpenAI API key or any API key that you're using, okay. You can put down the value, you can put down the key here like this. I have put it like this. I have entered my key here, okay. You can check your key with this, okay, particular thing if you want to verify, okay. So this is how you can add your secret key. Click on this particular button, okay. Type here environment, type the environment variable here, and the value of means the key here, okay. And you can save this, and you can save all the keys in this particular way, and you can delete also if you want, okay. At the time of pasting the key, double check that you pasted the whole thing and there are no extra spaces at the beginning or the end, okay. So sometimes that happens by accident when copying and pasting. It can cause problem later, okay. After you enter name and value, look for toggle switch here, you can see. So this toggle is labeled as notebook access. It is probably in the off position, as you can see. So basically what this toggle does is grant permission to the current notebook to read the specific secret. So think of it like you have just put a valuable item in your safe, but now you need to decide whether this particular notebook, the one we are using right now, is allowed to open the safe and use what's inside. So by default, Colab keeps secrets locked even from your own notebooks for extra security. So you have to explicitly give permission Okay, so like basically when I execute the particular cell of this OpenAI API key, it will ask the permission to grant the access, and if I click on grant access, then and then only this toggle will turn on like this. Okay, so this means you're telling Colab like I give this notebook permission to access the secret called OpenAI API key or any key, and you can turn access on or off anytime you want. Okay, so if you are working on a project that doesn't need a certain key, you can leave that toggle off and the notebook won't be able to access it. It's very flexible system. Okay, so as you can see, our toggle is switched on right now, so our secret is now saved and active. So in this particular way, you can absolutely add all your different API keys to Colab secrets using this exact same process. Maybe you have also a key for Google's Gemini AI or any other service called Hugging Face, or another one for search tool called Serper. So whatever keys you need to your projects, you can add them, and each with its own unique name. This way, all your sensitive credentials are stored securely in one place, and you can use them across your different notebooks whenever you need them. So it's like having a well organized keychain where each key is labeled and ready to go. Okay, so let's go to the document. Here we have the process. Like basically, this is the key secret option. We need to click on add new secret, and we have some question, add new secret, and this way you can add the keys. The question we have is, do we need to repeat the process for every notebook? So the answer is no, like you do not need to re-enter the secret's name or value for every single notebook you create. Okay, let me explain why. So because it's actually one of the best parts of how this system works. So Google Colab secrets are stored at the account level, not the notebook level. So what does that mean is, it means that when you add a secret key like OpenAI API key we just created, so it gets saved to your Google account, not this specific notebook, not that specific notebook in that we have created. So your secret lives in central vault that attached to your Google account. Okay, and that vault is always there no matter which notebook you open. Okay, once you add a secret, it stays in your vault and it's available to any notebook you open in the future, as long as you give that notebook permission to access it. Okay, we have one more question, which is, are the environment variable names are fixed? So the answer is also no, like environment variables names are not fixed. You can name them whatever you want, as long as the name you use in the secrets tab matches the name you use in the code. So like when you create a secret in the secrets panel, you give it a name like OpenAI API key, Hugging Face key. So that just a label, the name just a label. It's like putting a sticky note on the box that say OpenAI key inside. Now later on in your code, when you want to use that secret, you have to tell your code to go look for a secret with this particular exact name. So your code might have a line that says something like go to the value stored under the name OpenAI API key and use it here. If the name in your code matches the name you used in the secret panel, everything works perfectly. So the code finds the secret, grab the value and uses it. But what if the names doesn't match? Let's say you name your secret key OpenAI API key in the secrets panel, but then your code you wrote is basically something OpenAI key, okay, or my key, like something like, suppose here we have OpenAI API key name, but here in my code my environment variable something look like this: my key is equal to key something. Okay, so your code is going to look for a secret key called my key, not OpenAI API key, because in our code we have our environment variable name is this, and it's not going to find it because in your vault the secret is labeled as OpenAI API key. So the name have to match exactly, including capital letters, underscores, everything. If they don't match, your code will throw an error saying it can find the secret. Okay. So they are not going to find it unless you use the right label. So it works like that only. So this is very crystal clear. Like you can name your secrets whatever you want, but the name you use to create the secrets in the secrets panel must match the name you use in your code. If they match, you are golden. If they don't, you'll get an error. Simple as that. Okay. So with that, we have a conclusion. So in short, you have just learned how to securely manage API keys using Google Colab Secret, which is a critical skill for keeping your sensitive information safe, preventing accidental exposure of your credentials, ensuring your code is portable and shareable without security risk, and following professional best uses used by developers.
Now, once that is done, we need to create a client object per provider. This is what we're going to discuss in the video. You could think of this as the connection handle for the API. All of the models gets its own unique client object. Now, the thing with all of these models is that OpenAI, Anthropic, and Grok can directly read the key from the environment automatically. For Gemini, you need to pass it explicitly. So after you're done with this step, all 4 clients will be initialized and you'll be ready to go. Now, each of the provider returns response in a completely different format. And we're going to discuss that in the entire video. In short, what we're going to do is we're going to wrap each of the models, or the model names, slightly more accurate. We're going to wrap each one of them in a helper function. And what's that going to do is just going to hide the differences and always returns the same dictionary. And in that dictionary, we'll need 4 main things, which is the text, the latency, the tokens, as well as the models. So that's going to be discussed in the video. Now, the actual comparison, what we're going to do is send the same credit card dispute message to all 4 providers. And we're going to measure the results. We're going to see in the video that OpenAI took around 5.25 seconds, Anthropic around 3.2, Gemini 2.1, and Grok around 0.8. And we're going to discuss what insights we followed from the video that you're going to see later. Now we're going to discuss temperature and reasoning effort. These are 2 controls that people often get confused with. So we're going to be clear on both. Temperature is just going to be controlling randomness. Low temperature means more consistent. High means more varied. And reasoning effort just controls how deeply a model thinks before answering. But this only applies to reasoning models like the GPT-5 Mini. One thing to note, reasoning models, they do not accept temperature whatsoever. If you pass a temperature to it, you will get an error. And that's what we're going to see in the video as well. And we're going to see a lot of things like how we test the same prompt at different temperatures. And we're going to test it on the GPT 4.1 model. We're going to see how low temperature and high temperature responses vary in output. And we're going to see a lot of things like, for data extraction and even compliance tasks. We're going to be using the same prompt at low, medium, and high reasoning efforts as well, but this time on the GPT-5 model. And we're going to check out the output as well in the video. In this video, we're also going to cover Pydantic, which is a Python library that validates your data automatically. So your job is just to define what each fields look like. And if something doesn't match, it will raise a clear error immediately. Just a quick note, without Pydantic, bad data can travel silently throughout the whole system, and it can cause crashes in production. That's why having the Pydantic Python library helps a lot. A specific use case that we're going to discuss is when a bank gets 50,000 messages a day. And because of this, the AI can't return free text. It needs to be structured, machine readable. And that data should be routed automatically. So that's what we'll do in the video. We'll create a customer intent with all of these 6 fields: category, urgency, sentiment, entities, summary, and action. So for our credit card dispute message, the output should come back as follows, like dispute, critical, sentiment, what the sentiment is, all of the entities, the summary, as well as the action. We're also going to see how the responses API enforces the schema. So when you pass your Pydantic model to the API, the model literally cannot generate tokens that break the structure. It is enforced at a generation level. We're going to discuss this in detail in the video later. Now, one of the things that we're going to see is that not every provider supports structured outputs reliably. In this, you could see OpenAI and Gemini, you have complete native support. Anthropic has no native support whatsoever. And Grok only works reliably in JSON mode. We're going to check it out in detail in the video later. And we're also going to discuss how cost matters a lot in scale. We'll see how Gemini was the cheapest, which will be around 15 cents per million input tokens. And GPT-5 Mini being the costliest, which is around $1.10, and that is going to be 7 times more expensive. The reason is simple. GPT-5 Mini is a reasoning model. One of the things we're going to discuss is that Gemini is really good for bulk routing. Grok is really good for speed-related tasks. And GPT-5 Mini is only for complex edge cases that actually requires deep reasoning. We're going to see in the video how APIs go down, how even rate limits gets hit, how even models get deprecated. We're going to see how you should never really depend on one single provider. And that's the reason why we need a fallback chain. This is something that you're going to learn a lot about, why a fallback chain is really necessary. That's what we're going to discuss in our lab. We'll primarily have GPT-5 Mini, and as a fallback, we'll have Grok, and as a fallback to that, we'll have Anthropic. These are the things that you will see later on in the video, how the trainer is going to explain every single one of these key takeaways. The core terminologies that you're going to learn from this lab, all of that is going to be discussed, like input and output tokens. This is pretty fundamental. We're going to discuss how a token is roughly 4 characters or 3/4 of a word. We're going to see how an API call is built by tokens. We're going to see both what you send in as well as what comes back out. Key thing that we'll discuss is how output tokens cost around 3 to 4 times more than input tokens. Now, personally, the most interesting thing for me is LLMs versus SLMs. You probably heard of LLMs, but not SLMs. LLMs, you already know, it's just a large language model, like GPT-5, Claude Opus. Great for complex tasks, but we all know how expensive it is. SLMs are small models that could even run on a laptop. SLMs are really cheap to operate, and it's really easy to fine-tune as well. In practice, you should ideally be using both of them together. LLM mostly for decisions and SLMs for high repetitive tasks. One of the things that we're going to discuss is inference. Inference is what happens every time you call an AI model. So you just need to send a prompt and the model generates a response token by token. We're going to cover inference deeply in the video, following ahead. We're going to discuss in detail how every API call returns 2 layers. The server response is the full envelope, like, with the metadata, token counts, billing info, everything. And the model response as well, which is just the text that the model generated. Now, most beginners actually mix both of these up, and our trainer is going to cover all of it in really simple layman terms. Now, we already discussed Pydantic, but a Pydantic schema is a specific class in the library where you exactly define what your data should look like the type, the allowed values, as well as the constraints. In the video, we'll be combining OpenAI's responses API. We'll see how it enforces the structure at a token level. Don't worry, we'll also be covering LangChain, which is just an open source framework. It's going to be too much jargon at this point, but the trainer is going to explain this in a really simple way. Plus, we'll also be going deeper onto LangChain for the upcoming labs later on. Now, the last thing we're going to discuss are model snapshots. We're going to discuss how a model alias like GPT-5 Mini always points to the latest version, and it can also change silently. But a snapshot, like the GPT-5 Mini following a date, is pinned to a specific build and it never changes. So we're going to discuss about the aliases a lot while developing. So make sure to be tuned for that.
Fine. So in this, the agenda is we'll be going into the individual model provider SDKs. As I mentioned, the very option number 1, the proprietary models. We are going to access these 4 proprietary models directly from their SDKs. Okay, we'll be installing those SDKs. If you see, I'll be installing the OpenAI model SDK, Anthropic SDK, Google Gemini to access the Gemini models, and Grok is the SDK for accessing the Grok models. Okay, and towards the end, we'll also see how can we force the model to produce structured outputs using Pydantic schemas. Okay, -q is basically a flag to suppress the installation messages appearing on the screen or the console here. So that's a quiet mode. So short form of the quiet mode. Okay, without this, it will flood this entire, not entire, but a large part of the Colab notebook with installation messages. Okay, and pip install is to install these packages. Okay, these are the standard, Python commands you will find in every notebook at the start. Okay, we'll be installing few packages and then, running them by importing. Fine. Okay. So in this, as I said, we'll be directly accessing these models from their respective SDKs. And what we have done is the installations. And this installation will be a standard practice in each and every Colab notebook that I'll be sharing. So first thing we'll be doing is the installations. And these are the learning objectives. We'll be configuring the keys. You don't need to have all 4 of them. So let's say even if you have just OpenAI key, that's okay. So whatever key you have will work with that only. You don't have to really get all the keys. So Grok is free, open source. So I have already suggested for Grok API keys. You just search Grok API keys, and you will get the direct link from where to get the Grok API keys. I think I shared this link also yesterday. You will have to create your free account. Okay. And then on the top right, there is API keys. Click on that and you will be able to create your key. So the process is very similar. So you just write down some name if you want to set up some expiration policy, and then you can click OK, right? So that's a simple process. And for Gemini, again, depending on whether you are in the free mode or not, so you'll have to get this from Google AI Studio. Okay, so you just search for Gemini API keys, and I'll give you the direct link from where I created mine. And similarly, Anthropic API keys. Now, two differences between these two. Most important difference is the Gemini works in a post-paid model if you have exhausted your free quota. So postpaid models means you'll get a monthly billing. Okay. If you have exhausted your monthly quota or free usage, basically they provide some X dollars. I don't remember because I exhausted my free quota very, very long back. So I've been using the paid Gemini keys until now, maybe more than a year and a half. Okay. So for that, of course, you need to set up your billing and all that. But yes, this is the link where you will have to. So if I click, you will see two keys already operational in my account, and I have created some Gemini. Okay. So that is for OpenAI, I think, and how to add it to Colab. So if you just check out this, these are the direct links for Gemini API keys. And this is how you would be able to create your, yeah. So yes, you'll have to provide your keys in the secrets part. And once you execute, and if the keys are loaded properly, this should show tick marks by default. Now, whether the keys are correct, that is not being validated here. Let me repeat, whether the keys are correct and working will not be validated here. Correct and working, there are two different things. The key might be correct, but may not be working if you don't have enough balance in your account. So Anthropic works on a prepaid mode. So your account needs to have a balance. OpenAI works in a prepaid mode. Your account needs to have a balance. This is free. And Gemini goes in a postpaid mode. I've already mentioned if you have exhausted your free quota. Within the free quota, it will still be as good as Grok, right? So that is one thing you need to remember. So I'm importing all of these libraries and I'm setting up the clients. Now, where are these codes coming from? Okay, let me show you. So if you just go to OpenAI, um OpenAI API docs. Okay. So can you see? This is the same code which I copy pasted in my notebook here, the first function. Okay. So these are all coming from here only. I'm just showing you the source from where I have got these codes. Okay. So this is the official documentation page from OpenAI from where I have created the client. So what is the philosophy I'll discuss, but this is how you will get that initial codes. Similarly, Gemini API docs, that is the parent document from where you get the Gemini codes. Yeah, this is the same. You copy paste this. So what I have done is just to make switching between these models easy. Okay, I have wrapped all these codes. So I have just wrapped this code into a function. Okay, so that is what these functions are. So if you see, I've got 5 functions. So first 2 functions are for OpenAI. So this one is without using a reasoning model. So for the only difference here is here I'm using a model which is, can you see by default, GPT 4.0 mini, which is a non-reasoning model. And here I'm using a reasoning model, which is GPT 5 mini. And since I'm using a non-reasoning model here, I'm setting up a temperature. Again, the concept of temperature is known to everyone. Yesterday we have discussed lower temperature for more deterministic outputs. Okay, where you want more factual outputs. You don't want the model to hallucinate and make up facts. And for more creative outputs, you want the model to have a higher temperature. Okay, and for reasoning models, the temperature setting is not available. That is also what we discussed yesterday. So for them, there is another parameter called as uh, reasoning effort. Okay. Yes, I created all these So this entire code is my code. Okay, some
Okay.
parts of it which is being drawn from your official API documentation, and that's what I was trying to show. So even for the Grok model, if you see Grok Cloud, once you log in, okay, start building, it will directly take you to the platform, and within the platform on the right side, it will directly show you the. So go to the playground. Can you see this code again? You can use this, wrap it into a function, and that's what I have done here for the Grok. So same for Anthropic, Gemini, and all of them. Okay, so this is the same Grok code. Okay, so once again, let me have a quick recap. So for reasoning models, you will find the reasoning effort. And for non-reasoning models, you will find the temperature as the setting. So for example, Haiku 4.5, I have the temperature setting. For Gemini 2.5, I have the temperature setting. But if you're going for a Gemini 3 model, there you will have the reasoning effort as the right, because Gemini 3 onwards, it's all reasoning models, right? So same goes with Grok. Grok, most of the models have the temperature setting already. So once you get the output from the model. So let me just explain you the basic structure of any of these. Concept is similar for most. This is just to capture how much time it takes to and fro, making an API call and getting the result from that server. Okay. So how much time you are starting the timer, and here you are calculating the overall latency. Okay, so you are ending the timer here. So you are subtracting the start, rounding up to two decimal points. You will get the number of seconds elapsed up to two decimal points, right? So first you create that client and you are using the completions API, okay? And you are passing that same model name. And again, all of these will also have a system prompt and a user prompt. So this one shows the user prompt. This one goes to be a part of the system prompt. You can modify the system prompt as well if you want. This is your default system prompt I have already given. If you want to change that, you can change it here or you can pass it as a variable. That's okay. And this is your user prompt. If you want to change it or you want to pass it as a variable, both are fine. So these are your actual prompts that you'll have to modify, and this is going to work. So this is the place where you are actually making an API call. That entire server's response will be captured by this response variable, and that response variable has all sort of information. The first and most important information is the message dot content. Now, what is this message dot content? This is basically the AI message, or you can say the actual output generated by your AI model. Along with that, you'll have usage tokens, how much usage has happened, and then usage has happened means how many input tokens, how many output tokens, total completion tokens, total tokens. You also get idea about the run ID, model ID which was used, and then date, time, stamp of the API call, uh, overall, you can say reason for the model to stop generating. So a lot of other information, headers, normally what we call as the headers, are available. But I'm not interested in all of that messages right now. So I'm only interested in two things. What is the actual text of the model? Okay. Response, and the total number of tokens that is contained within that text response. So these are the two things I'm capturing for most of these models. So here text, and then here also I'm capturing the text and the output tokens. So in this case, for example, Anthropic offers both the input tokens and the output tokens separately. Here also you can grab the input tokens and output tokens separately if you want. Plus total tokens is also there. Fine. And then for Gemini again, you have access to metadata dot total token count. So see, the way you access all this information is different for each of these. This is all coming from the documentation pages. That is what I was trying to show. All these documentation pages. So all the codes, not only this particular lab, so all the subsequent codes, also the majority part has been coming from the documentation pages, which is the official. And then I attach my use case over it to make a full comprehensive storyboard. Okay. So that's how it is, because see, I cannot invent or create these codes, right?
That's
So for any model, if you are in an enterprise, then once you get the API endpoint for your model. You remember yesterday I was talking about that. Okay. So once you get the API endpoint for your model, you can write down a custom function which will make that API call to that model at that endpoint. And these are all very simple these days. You just go to ChatGPT, provide that endpoint, and ask the model to generate a Python function which will make a API call to that endpoint. It is actually that simple. Okay. So here
Being
I'm
on.
going to demonstrate what each block of code does. Explaining line
Okay.
by line most of the times will not be very much fruitful because you can anyway understand what this code is doing later by just copy pasting that code on ChatGPT. The important discussions that we want to have is why is this architecture being used? What are the other ways it is being used in the enterprises? What are the best practices? I want to spend more time discussing those rather than explaining line by line codes. We have a time constraint, so if you guys appreciate this approach, I'll stick to this. Maybe for 1 or 2 sessions, I can explain you every line of code, but again, I really don't want to get into that practice. Okay, make you used to that. Okay. If you really are completely clueless what is happening, this is the easiest thing. Literally go to chat gpt, copy paste that code, and explain me this code. Just say that explain me this code line by line. It's actually that simple. Okay. So you go to this at the start of explain me these codes line by line, and it will do this. Okay, I didn't even bother to change the model and all, whatever it is. I've just used as it is. Fine. So these functions are all wrapper functions. I've already told you these are all sending a prompts to the model, measures the latency, extracts the generated text, and the token usage. That is exactly what I have already explained at a high level, right? So this is the kind of explanation I want to give for all the functions, because if I try to explain in this verbose manner, we are not going to finish more than one lab in one day. And I have 29 labs and I have to finish that in next 15 sessions. And that is an impossible task. Okay. So you want to utilize more time in discussing the best practices rather than discussing line by line codes. So that's what I would suggest. Or if you want, you can do one more thing. Once you have the code with you, okay, you can ask ChatGPT to generate maybe more uh, comments or whatever, okay, to make it helpful for you or make it more user friendly, beginner friendly, depending on your level, okay. So that is exactly called as persona and flipped persona pattern. Whatever I just now mentioned is a flipped persona pattern. You ask the model to give an output for a beginner. Now the model knows that Prashant is not a beginner. That's the reason it's not giving me the codes with explanations, because I can literally look into the code and instantly figure out what is happening line by line, because this is what I've been doing for years. Okay, but if you want to modulate these codes for yourself, I strongly suggest that you help yourself rather than going back to the support team asking them to do it for you, because you know your current level. And if you spend this much of an effort, it will actually benefit you rather than trying to get everything pre-cooked. Okay. So that will still be useless. I can guarantee you that. Okay. Fine. So just to summarize, these are all individual wrapper functions making API calls to these models. And these parameter names are all coming from your API documentations. One point to notice here is the API endpoints are different. Number one. So what do you mean by API endpoint? Here, I'm using listen to me carefully. I'm using the completions API from OpenAI. Okay. Here I'm using the responses API. Dot create is the actual method or the function within that API. So each API can have multiple such functions. So here I'm using the messages API from Anthropic. I'm here using the generate content is the name of the function. So models API. And here for Grok, again, I'm using the completions API. That's exactly what we say. Okay, that's exactly what we say. Okay. And within those APIs, there could be multiple methods. So here the actual name of the method is create, and you can see these are the names of parameters. I just put my cursor, waited for 2 seconds, and you can see this is the complete list of parameters which are available to access within that API. Okay. So for example, maximum tokens, completion tokens, uh, modalities, and reasoning effort. Okay. So all of this, response format, stop reasons, temperature value, tool choice, verbosity. Okay. A lot of these are there. I mean, some of them can become deprecated or not. Now that will depend. So for example, even this completions API might become deprecated soon, I'm hearing. So you'll have to go back to the responses API. Even maybe by another 6 months to 8 months down the line, all these non-reasoning models will themselves become deprecated. So for example, GPT-4o models and below, they are already becoming obsolete and deprecated. So after 31st, OpenAI is not going to provide any support for GPT-4o, 4o mini, and so on. Even this 4.1 mini and those models are going to get deprecated in the next 3-4 months. Okay. So I would strongly suggest you to use the reasoning models beyond that time, like GPT-5, GPT-5 mini, GPT-5 nano, and GPT 5.2. Now we are already running GPT 5.4. I think I opened that documentation page yesterday and showed you. Okay. So these are the recommended models, I would say, if you want future proof. Not too much into the future, but at least next 6 months compatibility of your code base, then this is a better way rather than this way. Okay. This code may not work 3 months down the line. I cannot guarantee, but definitely this is going to work for the next 6 months as well. Okay. So this is very important that you know the life cycle of these APIs also. Okay. Fine. So this I have run. My helper functions are defined. And let's take a simple business scenario. There is a credit card dispute intake. So some random bank receives thousands of customer messages daily via their chatbot. Before routing a message to the right team, the AI assistant must understand the intent and provide an initial response. I will send the same customer message to all the four providers exactly. So my prompt and everything is going to remain the same, and compare their responses. So this is the exact message coming from the customer. I want to dispute a charge of 18,250 rupees on my credit card from the last Tuesday. I don't recognize this merchant called as Quick Mart online, and I never authorized this transaction. My card was in my possession the whole time. Please help me resolve this immediately. Right? And this is the system prompt again, which will be common for all the four models. Okay. So what I've done here is back to back, I'm making 4 API calls one by one, and you can see the results will start coming in. Okay. So I'm grabbing all the results into a dictionary. I'm grabbing all the results into a dictionary, and then using that dictionary dot items. Dot items is a built-in method for a dictionary where I am getting the key and the value pair. So provider is the key and value is the result. So I'm printing all the key value pairs here. So for the first one, GPT 4.1 mini, roughly 3 seconds it took for the entire API call to 50 tokens. And this is the response I have got, which is 720 characters in total. Okay. I have not printed the entire message just to make it short. Okay. But you can see here. So if you see, there is a function called as display result. This is what I've used. And I have only displayed the first, I have displayed the first 500 characters. Okay. And there is a if condition which says that if the total number of characters exceeds 500, then only print the first 500 and then make it dot dot dot. Okay. And also print the total number of characters. Okay. So that is the thing. So it's not going to print everything. It's going to print only the first 500 characters, but still it is going to tell me that total number of characters are 720 in the entire response. Simple. So here also the entire response is not being printed. I have only printed the first 500 characters, which is starting from thank you. And this message goes 948 characters. Okay. If you don't want to chop this off, all you can do is just comment this line. Just comment this line and we are good. Okay. All you have to do is rerun everything, unfortunately. Let me do that. So that's what, if you know some Python code, really you can help yourself a lot. Okay. Because if I, try to do all these modifications one by one, uh, so there was one more line here. Sorry, my bad. This was supposed to be chopped off. Yeah, this is the correct. So what I've done here is, I took out that colon 500 and now it will print the entire message. Now this is the entire, you can see best regards SDFC customer support. This is the entire message. This is the entire message for Anthropic, entire message for Gemini, entire message for uh, Grok model, Llama 70 billion parameter model, total of 558 characters. And let me do a side-by-side comparison. Okay, now these numbers will change because each and every API call to this model is probabilistic, it's not deterministic. And another reason it will change is we have used a higher value of temperature. Can you see? You have used a temperature setting of 0.7 in most cases. So which means you have already given it a lot of uh, liberty to be creative. Okay, because this was an email writing task, so it was needed anyway. So these numbers would have changed as I mentioned. Yeah, Grok shows the lowest latency. In fact, it is one of the best hardware. So what they have done is they have optimized their hardware for running these on their custom GPUs. So they have made some customizations. Uh, because of which it is really fast. And second reason is obviously the load on Grok is not as much as high as the load on OpenAI, Anthropic, or Gemini models. I mean, so that could also be a potential reason I'm suspecting. Okay, it's not purely an artifact of the inference hardware. So how many or what is the server load, that will also somehow matter a bit. Right. So here the word accuracy is, I'm assuming that if you are running, you would have the responses on your screens as well. Okay, now we want to check how does the temperature and reasoning effort change the outputs. Okay, so this is very important concept. So temperature, as I have already mentioned, these are for older generation models. The newer generation models, they are reasoning and thinking models. So for them, the correct is the depth of thought, internal chain of thought. So these models, reasoning models, why we are calling them as reasoning models and how they are able to reason. So they have been trained on COT data. They have been trained on COT data. What is a COT data? Chain of thought data. What is chain of thought? We'll learn in the chain of thought prompting technique later, okay, in the session today. So simply means that a data set was prepared. Okay, you can say a data set was prepared in which there is an input prompt. And let's say this input prompt could be about any question, could be about any task. Okay, so some input prompt is there. And for each of that input prompt, okay, the output was generated using the chain of thought prompting technique. Prompting technique. So this chain of thought prompting technique will give you all the detailed steps and reasons because of the chain of thought prompting technique that we will see. Okay. And so this is the kind of output you got. So now just this is one input output pair. This is one input output pair. Now just multiply that by maybe 10,000. Okay. So if you have 10,000 such input output pairs, then looking at the level of detailing, looking at the kind of, steps to arrive at the final answer or the final conclusions, it directly doesn't jump into the final output. Okay. Model goes through these steps of reasoning. Okay, because of the chain of thought prompting technique. So then model by default knows that if any such similar input comes, I have to generate this entire chain of thought process internally, and this is the output which I have to provide. So a chain of thought data, this is what we call as COT data. Okay. And DeepSeek models were actually created using this COT data, and they use ChatGPT models to create the COT data. Okay, that's a very popular thing that you will find on the internet. Okay, so they actually use ChatGPT models to train their own models. They didn't have money to purchase data. So how did they generate data to train their models? Literally, they made 10,000 API calls with a proper prompt engineering technique. They got the model's output, and that output was a very, very structured, neat, and clean output. You cannot see these days, quality matters more than quantity. Instead of having millions or billions of input output pairs, which are just raw text from internet with all sort of punctuations, hyperlinks, images, I mean, corrupted with a number of things, and then spending months to make it clean, and still the model is struggling to identify the pattern and the context and the meanings. That is the raw approach which these three model vendors used, because they had that much time, money, and effort, and processing capabilities. But this small company, DeepSeek, they didn't have all of that. They again had very less number of GPUs as well, so they didn't have access to that kind of data as well altogether. So they took an intelligent approach. They understood by that time that data quantity is no longer a big you can say factor. Data quality is a bigger factor. So even these days, please listen to me carefully. Even these days, there is a growing trend of creating small language models, okay, specialized small language models, which have been trained on, or you can say fine-tuned on, okay, very high quality, domain specific, task specific data. And these small language models, when they have been trained on very high quality domain specific and task specific data, this data is not huge, maybe just 1,000, 5,000, 10,000 data points at max. The performance of these small language models is much, much better than your even Opus model. That's what people have figured out. Your smartest model, Anthropic model, Gemini model, Claude model, whatever, uh, OpenAI model you are using. Okay, so that is exactly that growing trend. So companies these days are not at all focusing on the bigger models if they want, or if they have a use case to build a model on their own. If they have a use case to build a model on their own or fine tune a model on their own, then they are not going to take a huge model like DeepSeek. DeepSeek model, I told you, is 670 billion parameter. No one will take a DeepSeek model and fine tune it. Okay, that's very. So instead, take a 270 million parameter model and train on a very high quality data set. So that's going to be a better approach. Again and again, I am repeating, if there is a use case for doing this, most of the times people are not even aware whether they should be really doing this or not. Okay. So that's a different discussion altogether. We'll not get into all that. We have already spent enough time yesterday in all these discussions. Okay. So, yeah. So newer generation models are reasoning models. They have been already trained on chain of thought data, and I've already showed you how a chain of thought data looks like, and that has been generated by using the chain of thought prompting technique. So let me take another business scenario here. Investment summary generation. A wealth management team wants to understand how output variability affects client facing documents. Okay. So if you want deterministic outputs, which is preferred in case you are generating compliance reports, you should be using low temperatures. While if you are going for marketing drafts, you should be preferring higher temperature values. So here I've got a prompt. Write a two-sentence summary of why diversification matters for a retail banking investment portfolio. And I'm using three temperature values. Let us see the kind of outputs we get for each of the temperature setting. So diversification matters for retail banking customers investment portfolio because it helps. Is it exactly same? Okay, the reason it is exactly same is the temperature values, but this is very strange. So these are the temperature values. Okay, and then I'm iterating for these temperature values, and for each temperature value, I'm calling that OpenAI model. with that temperature. Okay. So what is the temperature I've set? 0. 0.7 as the default, which will be overwritten by this temperature value anyway. So, but this is strange. Why we are getting exactly same? Let me check it again. There should have been a difference. Let me try other models. Same prompt, 3 runs at 0.9. Here I'm using 0.9. Again, at 0.9, I should have got 3 different responses. Okay. But here I'm still getting same. Maybe I might have changed something at the top, which is, let me check. What did I change here? So temperature is fine. I'm using the call OpenAI. Okay. Okay, let's take the other model. Ideally, again, these should have been quite different. And of course, I'm not surprised these are same because these are anyway same. Okay, which means it is literally ignoring temperature as of now. That's what I can see. But let's see for the other models, how is it different or same? This one is for a reasoning model. Okay, let me run this for a reasoning model. And now the 3 reasoning efforts are low, medium, high. There is extra high also, X high in some cases. Okay. So this is a simple system prompt. You are a senior banking analyst. Also explain the mathematical concept behind risk reduction through diversification. So some additional thing that I have added. And when the reasoning effort is less, this is the response I get in 9.41 seconds. Now, if you see this response time has increased from roughly 1 second to 9 seconds or 9.9 or almost 10 times it has become. And the reason for that is the first 8 seconds it takes for reasoning, thinking. Okay, so that is probably delaying all that responses. Fine. Now here I get diversification matters because spreading money across many different assets reduces the impact. Okay, fantastic. And in the case of high reasoning, can you see there is a very clear, there is a very clear less, more, and then most. So this is exactly what you call as the highest reasoning effort. It is taking much more time. Also, the number of characters might still be the same in the overall output, but literally it is taking more than 40 seconds for reasoning. Here it is taking more than 9 seconds. Here it is taking more than 8 seconds for reasoning. So 8 seconds for reasoning, 9 seconds for reasoning, and roughly more than 40 seconds for reasoning, because output generation would be still 1 to 2 seconds only, because the length of output is still more or less the same in all these cases. Okay. But of course, since it has done a more effort in reasoning, this output would be much better in terms of quality, in terms of trust. Okay. And maybe it also would incorporate various views. Okay. Much more robust, comprehensive, these words I can use. So reasoning effort, okay, doesn't add randomness, rather it adds depth. That's what I said. So this answer will become more comprehensive, you can say. So reasoning effort adds depth. The model thinks harder at high reasoning, and this will produce results after more thorough analysis. Output is more or less still deterministic for the same input. What it means is if you rerun this, the kind of output that you have got for each of these 3 reasoning efforts, that will still be consistent. And that is the meaning here when I said output is still deterministic. Okay. So for compliance reports, I prefer to use again GPT models which are low temperature setting. Once these guys become obsolete, then go with a high reasoning effort. Okay, if you want to do more complex financial analysis. Okay, so prefer high reasoning if you don't have access to these models with temperature setting. Okay, now another scenario where we want the model to, or we want to force the model to produce a structured output. Let's say a small business use case. customer intent classification at scale. So some bank processes 50,000 customer messages daily. Instead of free text responses, the intake system needs structured machine readable classifications that can be directly fed into routing rules, dashboards, and CRM. So we can use Pydantic. See, the main advantage of Pydantic is it already enforces. So enforcement and validation both are included by default, and you don't have to write down any additional code. Let me repeat that last statement. The advantage of Pydantic is it not only validates the inputs and outputs that each data type belongs to the specified data type as you expect or as you want them to be, but it also forces. So enforcement and validation both are included in Pydantic by default, right? So a simple example here is now, this is fundamentally different from LLM to return a JSON. So one way that we could have done is ask the model as an elaborate prompt template to return a JSON file. That is what I'll show you in the next lab. Okay, there is a notebook where I'll show you how to return a JSON file, but that would not be consistent. Okay, sometimes that JSON file also fails. But if you go with structured output with constrained decoding, 100% times it works. Okay, so it's highly consistent, highly reliable kind of thing. Okay, so from Pydantic, I'm importing the base model and the field definitions. Okay, so and also this literal from typing. So I'll explain you each one line by line. I'm creating a simple class. Now this class is what we call as Pydantic schema. Okay, this class is nothing but a Pydantic schema. Okay, this is a Pydantic schema. So what we created is a Pydantic. So if you remember, the previous response is a free form response. Okay. Let me show you how the response looks like. I mean, it seems that many of you have never seen a raw response from a model. And let me check this. Uh, I would need the model. So let me directly provide the model here. And to be medium. So these two are there. And I need the prompt. Okay. So there's a customer query and there is a prompt. Okay, no worries. Customer query and a system prompt. So this prompt is nothing but system prompt plus the customer query. Let's see how we get this. Okay, so let me show you the raw response now from OpenAI. So this is the response that you have got from OpenAI. So I told you that you will get some response IDs, date times, if there are errors or incomplete details, other instructions, you will get the model ID, run IDs. This is your run ID. Okay, type reasoning, all of this. So not interested in all of this. I'm mostly interested in the model's output, which is coming from here text part. So from here till this point, till this point, I think. So what you do is do a response.text. I think this will work. No. So here, how did I extract? Just a second. OpenAI output text. Okay. Output text. Let me check. This should be an output text. Yes. So this is what we have got. And let me print the output text. Okay. So this is the output text coming from the model. Okay. This is the actual response. Okay. LLM's reply, I would say. Okay. This is the entire response from the server. This response is the entire response from the inference server. Because model will not give you the response ID, date, time, tokens, and this and that. That is all attached by the application layer, which is serving that API call. So that is actually coming from the server. This response is the server's response, not the model's response. So model's response is only this much. So
Got it.
most of the times we are interested only in the model response, and
Model
that is what
response.
we are capturing here. If you uh, noticed, so in most of these cases, I have
So,
captured the model response. Here also I'm capturing the model response for printing. Here also I'm capturing the model response for printing, model response for printing. So this is the line where the actual model response is being captured. So model, now here if you see the models, so this is the model response, okay, which is a free from text. So I mean so many things. Now when I show you the model's response after attaching Pydantic, all of these things will come as like a Pydantic schema. So let me show you. I think that will make more sense. Where is, yeah, okay. So let's understand what are the fields I want. Okay. So for example, I want these fields. Okay. So one field is category. So I'll get one response dot category and whatever value it is. Then this will be present in my response as response dot urgency, and I'll be able to access sentiment. How is the sentiment present in my response? Response dot sentiment. So I can access each of these fields directly by using response dot response dot response dot response dot. It's not going to give me a string, which was the actual output. Can you see the model's response is a string here,
yeah.
correct? Here the
Okay.
model's response was a string, isn't it? The entire model response is a string. This is a model's response. Okay. Now this time when you attach a Pydantic schema, the model's response itself will be in a structured format and which will contain these fields automatically. So that is the biggest benefit. Okay. So there is no post processing needed. You don't have to later on. But if you still want to convert into JSON format or a dictionary format, it can still be done. This
That's
is
what I
your
mean.
template. Correct. This is your template. So you are providing which fields need to be present in the response. These are the field names and that is the field description. Correct? So
Okay.
field name, field description, field name, field description, and the data type. So what do you mean by literal? Literal means the model is supposed to select one of these five values. It will not generate the value of category. It will not hallucinate the value of the category. It will select one of these appropriate values and map it to the category. So in this case, sentiment, it will take one of these five values, four values, sorry. Okay. It will again pick, literal means pick one of the values. Okay. Entities will be a list of strings. Can you see this is a list of strings? So these entities will be extracted from amount, date. So there can be amount also in the entity. There can be a date also in the entity. There can be some merchant names also in the same entities. So it will be a list of entities and each entity itself would be a string. So that is the thing. And here the summary will be a string directly. Summary will be a string and recommended action is also going to be a string. So these are the data types that you have attached. Okay. This is not post processing. Okay. We are going to attach this Pydantic schema to the model right at the time of making the API call. Okay, so later on I'll show you how you attach a tool. Similarly, we are going to attach this Pydantic schema. We are going to bind. So there is a specific method called as with structured output. I'm going to use that with structured output. Okay, so let's have a look at that. So using OpenAI response API to force the model to produce a structured output. So let's say there is a text message. I want to dispute the same. I think this is the same. And this is to calculate the latency responses API. And here I'm doing the parse. So here the endpoint that I'm using is a parse. Okay. Not directly. So if you're using all of these or doing all of these using LangChain, LangChain is a different framework. We will talk about that maybe in the next week onwards. Yes, we'll be creating our first agent, LangChain agent. So we'll talk about that. And in that case, it provides a different method to force the model to produce a structured output, and that is with structured output. there is a specific method called as with structured output. We'll be using that more extensively. So for now, I'm using the parse method coming from the responses API. You provide the model name, whatever input output it is. So here is the system prompt, and here is the user message, which is this, and the text format for the output. So this is how you are attaching the Pydantic schema for the model to refer. Simple. This is the exact place where you are attaching the Pydantic schema. So now the
Yeah.
model is not going to reply like a text. It is first going to refer to this Pydantic schema, and the response will come as per that. Okay. So you just have to get the output parsed method. Okay. And this output parsed method will have all these uh, things. Okay. So this is your final output, which will be used to access the individual fields. So if you see, so this is the actual, so when I say output parsed, so this contains the output as per the Pydantic schema. Pydantic schema. So I told you that response dot category. So just imagine that this is your actual response, the final response from the model after it has been, adhering to the Pydantic schema. So this is your actual response. So response dot category, urgency, sentiment. So we are just accessing the values and printing it here one by one. Okay, I'm just accessing the values. Okay, so if you want to see the intent, how it looks, maybe just print that intent. And that's your Pydantic model. So if I just print the data type, it will tell me that it's a Pydantic model. Okay. Yeah, that's actually a Pydantic. So it's not JSON. Once again, let me reiterate. It's not producing as a JSON, but if you want to convert that into a JSON format, it is possible. Okay. So the actual intent itself is a Pydantic model. It's a Pydantic based model. So this is what, where is
Okay.
JSON in this? There is no JSON in this. Okay. So that's why I was repeatedly saying there is no post processing. So if the model is giving output in a different format and then it gets processed, that's a two-step process. Okay. So there are output parsers in LangChain, which we normally use if you really want to do post processing. But Pydantic schema actually forces the model to produce the output in that structured output format itself. Pydantic is the default now. These days, no production level code is created without Pydantic. Pydantic is default, de facto standard, you can say. So everyone is using Pydantic extensively. Of course, there are different other techniques like unit test and those things. But Pydantic schemas are the easiest, or Pydantic models are the easiest ways to enforce type, you can say type defs. Yes, because see, Python is a dynamic typed language. We don't create the data type, or we don't enforce the data type of a particular Python object at the time of object creation. And that's exactly the philosophy behind Pydantic. Let me repeat, if you want to create an integer, you simply say a equal to 5. By default, a becomes an integer because you are assigning a value of 5 to a. If you say that b, you want to create b as a string, you don't have to initialize a and b, like for example, int a and then a equal to 5. This is the syntax you would find in other programming languages where you created. Correct. So this is not the philosophy what Python follows by default. The moment you say a equal to 5, Python will create as an integer. Okay, and later on you can assign a as hello also. But in this case, it will force because you have already go back to Java, and if you say that a is an integer, you will not be able to assign a string to it. But this is not the philosophy what Python follows, and so you can assign it to an integer, you can assign it to a string as well at any point of time. So then how do you enforce type settings, or strict type definitions, okay, to these um, variables? So that is the gap which is being partially solved by your Pydantic in a way. Okay, so Pydantic enforces or makes sure that each function gets their input in the required format, and the output of those functions are also in the required format. We'll show you that later. If you see, uh, it's not here, but when we create these agents, Okay, there will be node functions. I'll show you the node functions. The output of the node functions will also be Pydantic models. Ideally, yes.
Oh,
If you are attaching the same Pydantic schema to a different model from a different vendor, okay,
mm,
theoretically
yeah,
it is supposed to stick to the same Pydantic model. However, what will be different? The way you make the API call will be different. So here I have used the parse. Okay,
correct.
so that will change if you are looking for a Gemini model to stick to a Pydantic schema. That endpoint may still be the same, but the method name would still be the different. So that is what you have to
Right.
go through the documentation and find out. Okay, and this
That
is
is
a
what.
big headache because if you want to switch models seamlessly for each model, it's very difficult to remember the so many number of endpoints, right? So that is the problem solved by LangChain. We'll talk about that in the next lab. Okay. So we'll extensively use LangChain. This is the only and only notebook where I have not used LangChain. So rest all the notebooks will use LangChain because switching models is very simple. The endpoints are all same behind the scenes. LangChain does all that abstraction, takes the headache of parsing it to different models using their respective APIs and SDKs. All that headache is internally handled by LangChain. As a front end, I get a simple, neat and clean API endpoint which is same across all models. So that front end is provided to me by LangChain. So we'll do that in the very next book itself. We'll be using that in LangChain. So we are going to do that. So just let's see. Okay. So here, what are we doing? Acha, I think I've explained that. Yes. So classify five diverse banking messages. So these are a list of five messages. And for each of those messages, okay, I'm using the GPT-5 mini model, same system prompt, but the messages are changing. Doesn't matter. The point here I'm trying to highlight is whatever be the input now, as long as your Pydantic schema is the same, those fields in the output will remain the same. And that's exactly what I'm trying to check here in the end. Okay. So each of them will have the category value, each of them will have the urgency value, each of them will have the entities, each will have them the recommended action. And that is, see, if any one of them doesn't have the category, what will happen? The code will give you an error in that line, isn't it? But if the code is running for all the five messages, it clearly shows me that for irrespective of whatever be the input, the model's output is structured and same, following the same structured format, right? And that is the main learning that we are getting from here. Okay. Now, but take your time to read the individual messages later, but this is what I wanted to demonstrate at a high level. Okay. Uh, okay, so not all providers support constrained outputs natively. So there is one problem with the Anthropic model. So they use a prompt-based JSON extraction and manual Pydantic validation. So this is it's a bit tricky to do a similar thing with Anthropic if you are using directly. So if you want to enforce the same thing, I would prefer to do via LangChain because LangChain will do that headache, whatever method I have provided here. Okay, so for example, OpenAI uses the parse method which I used above, right? If you are using the responses API, if you're using the completions API, you would still use the create method with the response format set to the Pydantic model. Okay. If you're using the Gemini, then generate content, which is what we have used above, but apply a response schema equal to Pydantic model name. Same thing. If you're using the Grok, again, Grok does not support everything as such, but it supports only a JSON object, not a Pydantic model schema directly. So here, Grok is also an outlier, just like Anthropic. Fine. So one example here I'm giving. So JSON schema output. So this is like I'm going to attach this JSON schema to these models. So the output will follow the JSON schema, although it's not a true Pydantic thing, but still it will try to adhere to the JSON schema format. Okay. So the message is still the same. I'm asking the model to return only the JSON matching the exact schema. I'm providing the exact schema. The vertical pipe means it will select one of these values. Okay. And entities will be list of key entities. Okay. Summary will be a one sentence summary, and this will be suggested. So it will infer that this is supposed to be a string, this is supposed to be a list, this will be supposed to be one of the string values out of these. So that is all inferred by the model. Model is intelligent enough because this is being provided to the model as a input prompt. It is a string. You are not providing this as a JSON format. This JSON format is embedded within the string. Remember that. So these three double quotes start and three double quotes end. Can you see? So entire thing is a string. So this JSON format is embedded within a string. Ultimately, model will only take a string as the input. So whatever format that you are providing, that format is still embedded within that string itself. So model will read that JSON file or JSON format, sorry, and will infer on its own because of the reasoning that probably category will be one of these strings. The way I am reasoning, the same I am expecting the model to do that. It will do that. Urgency will be one of these strings. Sentiment will be one of these strings. Entities will be a list of the entities because output format is a list. You can see the square bracket. Summary will be a one sentence summary as a string. Recommended action will be a string again. So that's what the model will reason on its own and give you, hopefully. Yes, exactly. So if you are looking for really a reliable model, then you better go with. So here in this case, what happened? There is a parser validation error, and the reason for that is the output format is not exactly the same JSON schema that I was expecting. So Anthropic still failed, but Grok qualified. Let me repeat what has happened here. Why is the parsing failing? Because the model's output schema of that JSON file does not match with the input that I had given. So maybe the next time I run this, it might match. Who knows? It's still not matching. So can't help. If you want to really make it more reliably uh, match the output JSON schema, you'll have to probably play with the input prompt or do some more post processing, whatever. You will not make the choice. Your IT team will make that choice.
Okay.
Your solution architect, system architect will make that choice. I'm assuming that you are building the product here. If you are
But
the solution architect, then you are in the wrong course. We normally run a Gemini for Leaders course where the entire 24-hour course, we don't build anything. There is not a single line of Python code in where I teach in those 24 hours. The only discussions that we make is how, what, why. That's it. Not how means how to write down a code. So it's only decision frameworks we are discussing. So please get in touch with the team. Mostly every company will have one or two max to max these kind of solution or GenAI architects who knows all of these nuances about these models. So they are the one who will decide.
correct.
It not only depends on the business case, it depends on the uh, costing. It will also depend on the quality of the outputs. Obviously, it will also depend on the client's use case, or if it is for the company's own purpose, it will also depend on the client of access where these models are hosted and many other factors basically.
Okay.
But let's say if you're doing it for your personal project, I would suggest you to take the best model and the easiest model while learning, and which is in this case OpenAI almost. The reason for OpenAI or Gemini models is the documentation is very extensive, and most of these models have already been trained on these OpenAI's documentation themselves. Okay, and even I have found lot of discrepancies in the codes generated by Claude using their own API documentation. But the codes generated by Claude for OpenAI models, they almost work every time. And why is that happening? Because it's not only the documentation, the entire internet is filled with OpenAI codes. And that goes as a training data also. So when your models have seen millions of code base working with OpenAI models, they will more deterministically generate codes which are reliable, trustable, and working codes using OpenAI endpoints rather than those specific other vendors, let's say if you are going for DeepSeek model code, or let's say Kimi K2 model is a very, very popular model. But if you ask Claude to generate a code for Kimi K2, 99% it will fail, because Kimi K2 just came 3 months ago or 2 months ago, somewhere in the first week of Jan. Okay. And so that may have not even gone into its training data at all. So model has no idea what is Kimi K2 even. Okay. Many times I have seen that even if I ask the model to use GPT 5.2, it goes back and changes the model name to 4.1 mini or 4.0 mini. It doesn't even know that there is something called as GPT 5.2 model even exists. This is the problem. So how can it generate a code? So if you are writing your codes, then I mean, I'm assuming you are already proficient enough. But if you are going to take help from these coding models or coding assistants, vibe coding facilities or IDs, that means 90% dependency is there for you to depend on these models. Then go with a model which is slightly older, more stable, and for which there would already be enough code base available, so that these models would have learned the coding patterns, the response patterns, and every other ways these models can be used properly. And so the outputs will be immediately useful and usable. I mean, is that making sense? Okay, but if you are asking
Correct.
ChatGPT to generate a code using GPT-4, it will itself fail. Even ChatGPT cannot generate a code which uses GPT-4, because it has not seen its own documentation. Whereas that GPT-4 model was trained 6 months ago using
Yeah.
an earlier model's data. Okay, so these are the nuances. So if you are really proficient enough to know what is working, what is not going to work, then feel free to experiment. Yes, stakeholders, yes, Karan, absolutely. Okay, so that is done. Cost and latency analysis. This is just quick comparison between the pricing. I would strongly suggest you to refer to the actual model pricing page if you are looking for Anthropic model pricing. So this is the keyword you would be searching: Anthropic model, Gemini model, OpenAI model. Just change the model name here, and you will get the this Opus model will give you, I think, $75 for the output tokens.
Okay.
Uh, Go to the pricing API. Yes. Opus is 25. That is 25. That has decreased. Earlier it was 75. They have decreased. And this was 15. This was 15 and this was 75. Now they have decreased it to 5 and 25. Okay, when this was newly launched. So that is the kind of costing sometimes. Even GPT-4 model is very expensive. If you see uh, OpenAI model pricing, API pricing. Yeah, so it is 2.5 and 15. So quite costly compared to other models, which is GPT 5.4 mini nano. And if you compare this with respect to GPT-5 mini that we are doing or using in these hands-on, that is like 100x difference, literally. Okay. I'll tell you, directly go to the models page and they will tell you. So we are looking in the wrong page for those information. Okay. So go to the this page, OpenAI models page. Directly go to the models page, and for each model, you will see whether it is reasoning or non-reasoning. I'll show you that. Okay. So here it clearly tells me that this is for agentic coding and professional workflows, and this is a reasoning model. That is the reason. Extra high is also there. Okay. And this is a model for coding, computer use, GPT 5.4 mini. This is our reasoning models. And if you want to use a non-reasoning model, go in the comparison mode, select GPT 5 mini or 4.1 mini. That's what I have been See, model's capability will not change whether you access the model from whatever platform. Model's capability will not change depending on where it is deployed and how are you accessing it. Okay. So if the same GPT 4.1 model is deployed on Azure or AWS or your company premises, if it is a non-reasoning model, it will remain non-reasoning. You cannot get it to reason and output the reasoning tokens. It is as simple as that. So that is how this model was trained. You just take a dump of that model and deploy it on Bedrock. Take a dump of that model and deploy it on your own premises. Take a dump of the same model and deploy it on Azure. How does see that is what we call as model snapshot. Okay. And if you want to know the exact model snapshot, you can see this. Usually, I'll show you. So go to any of these pages, click on these models, and the snapshots are usually having these kind of yeah, so this is the snapshot. So whenever we call 4.1, this is the snapshot which is actually used. So snapshots usually have a time. And this time can change because this GPT 4.1 model also was trained 2 times or 3 times. It can happen. Without changing the architecture, with a slightly newer data, the model was retrained. And so the available snapshot date will change. So as long as you are using the same snapshot, capability cannot change. So snapshots usually will come with a date timestamp also. So this is a snapshot when it was released for public use, not the cutoff date time. Once again, the knowledge cutoff date will still be different. So if you want to see the knowledge cutoff date, it will be mentioned somewhere. Yeah, here. This is the knowledge cutoff date. That is 1st of June 2024, and that is not same as the snapshot date. So that was 1st of June, and this is 14th of April 2025. So what happened between that? So those 8 to 9 months it took for the to process the data which was cut off in 1st of June 2024, right? So from June to next April, it's roughly 9 months, isn't it? So what happened in these 9 months? The entire data was processed and the model was trained. So model training itself might have taken 2 months. The data processing and other things, fine tuning, alignment tuning, RLHF, all that process literally took that 9 months. So that snapshot was publicly released on 14th of April next year. Whereas the cutoff date for the knowledge was 2024, 1st of June. So that's typical 8 to 9 month cycle. So more amount of data needs more amount of processing and more headache also, right? So let's come back and finish this. So the actual pricing you will have to fetch from these respective pages. That's how you would get there. And let me see. Okay. Now, what is this? Suppose the API call to a particular model fails for any reason. Maybe the server is busy or server times out, the network latency, or maybe there was a slight disruption in your own network. And number of reasons could be there that this model API call failed. Now, there can be two things which can be done. First, you can retry the same model or you can retry using a fallback model. Okay. Now, it depends. The reason why the previous API call failed. If it is failing because of the server issues, the second time also it might fail because the server is really busy with a lot of a number of things. Okay. So usually the fallback model is chosen from a different vendor. Okay. So if my original model is, let's say, 5.1 mini, my fallback model is from Grok. Fine. This is a usual practice. The fallback models usually is chosen from a different vendor because if this model is still busy, okay, like for example, OpenAI server might be down. You never know. Okay. Or your account might have got zero balance. Then what is the point in trying? Even if you try 1000 times, all your API calls are going to fail, isn't it? Because your account is having a zero balance. Or the third reason could be authentication error. Your API key might have got expired. So authentication error is your 403 error. Okay, rate limit error. I mean, your keys have already reached the rate limits. So my account is currently in the tier 3. Okay, your accounts would be in tier 1. I have got 3 times more usage limits for the same model. Okay, so it is less likely that my API call will hit a rate limit error. So there are rate limits, token per day, token per minute, and request per day and request per minute. If you go to any of these models, you can at the left side go to your, if you just go to OpenAI play platform.openai.com, and I'll show you where you can find your rate limits. Go to this usage or any of these dashboard. Go to dashboard or even settings, I think, on this side. So go to settings, this settings gear, and from there go to the limits on the left side, and then it will show you model wise limits. So you have token limits and request limits. So this is tokens per minute and this is the request per minute for my usage tier, which is in the tier 3. So for you, these limits will be much lower. Okay. So if you are hitting your usage limits for any reason, you'll get a 429 error. So the error messages can be quite different. So if it is a server error, you might get 500 error, 503 error, 502 error. If the API endpoint is not found, you will get a 401, 404 error. If you get an authentication issue, that is your expiry of the API key, 403 error. Or if it is a rate limit has been reached, you'll get a 429 error. So these most common error messages you can find from ChatGPT. Just ask ChatGPT what are the typical HTTP REST API error codes you get, okay, and their explanations. So these are the typical nuances. In enterprise grade, there are 3 levels, in fact, not even one. This is what we call as one level fallback. There are mostly 3 level fallbacks. So I
Yes.
also normally implement at least 2 level fallbacks. So 2 level fallbacks means if this model also fails, there is another fallback model. That also fails, there is another fallback model. So you can have, so the first fallback, if you're maintaining 3 level fallbacks, if you're maintaining 3 level fallbacks, then the first level fallback can be from the same vendor. You can try that because many times I've seen that Opus fails, but Sonnet works. If you go to the status of your Claude, you go to this Claude status. So what I'm trying to say is, this is one page you can check. And many times I have observed, many times, and you will find this across Reddit's threads and many places, those discussions. Opus models, because of heavy traffic in peak times, will give you a lot of error. I mean, that will stop responding to your calls altogether. Even today there was an outage. You can see. Okay. And most of these outages are affecting the Opus model these days, Opus 4.6. But the Sonnet models and the Haiku models are still working perfectly fine because load is less. Because let's say I am on a max plan. Most of these guys are now going with the max plan, which means 24 by 7 the model is running some or the other task. And almost always, literally, ever since I have gone into the pro model and the max plan of Claude, I have been explicitly using only Opus 4.6. I have literally never used or stopped using the Sonnet and the Haiku models. Okay, so anyone who is in a paid plan of Claude, I have observed that they are almost explicitly using Opus only. Okay, which means there is always a heavy traffic on Opus 4.6 model. So I have observed personally that the Opus 6 model API calls do fail. Whereas in the same instant, if I am giving a fallback as Sonnet 4.6 or Haiku 4.6, it immediately works. The quality might be 90% or 95% of the Opus, but it depends on your task, how reliable you want it to. If it is an agentic task, then probably you'll have to handle it a different way. Then you better select a equally capable model from Gemini, maybe like Gemini 3.1 Pro model, which is equivalent to Opus. But if it is a regular task, maybe customer intent, query categorization, sentiment categorization, or generating an email, why do you need Opus 3.4.6 model every time anyway? But let's say you are using it because your company has provided. So if that during surge times the model is not available, we can still very easily use Sonnet 4.6 model for generating a summary or generating an email. I mean, that's quite reliable task, even for those models which are quite capable of doing those. Okay. So my suggestion is, if you are maintaining three level of fallbacks, the first level of fallback should be from the same vendor itself. Select a different model, a lower capable model, not a bigger capable model. Then there's no point in doing the fallback. Okay, because a bigger capable model will always be more busy, okay, in terms of busy in terms of API call handling, number of requests that it is getting, okay, the flood of requests it is getting from multiple people. So take a smaller capable model or lesser capable model, lower version model, whatever word you want to use, from the same vendor, and then the second and third from the different vendors. That's how it can be. So if it is two level fallback, if it is one level fallback, then definitely the other fallback model, this is the one level fallback, this is exactly what is called as a one level fallback. So then the fallback model has to be from a different vendor. Okay, so next is on prompt engineering. Okay, let's see. uh, LLMs, everyone knows, this is also clear. Okay, most important thing in prompt engineering is this RCECI framework. This is a term coined by me, so you will not get this anywhere else. And this works. So you might get a different name, variation, whatever, but this is easy for me to recommend, recollect, apply, implement, whatever you want to say. So R is for role, T is for the task, C is the context, another C is the constraint, and I is for the instructions. So these are the five key elements your prompts must have. Okay. So role is basically what you want the AI model to be. What kind of a expert persona the AI wants to assume, or you want the model to assume. So for example, you are a senior AI ML expert, or AML is your anti-money laundering expert, or banking, maybe credit risk assessor, or if you're coming from a healthcare, your medical transcription expert, or marketing side, then you are a SEO expert, or sales expert, whatever. Okay, or you are a certified financial planner, or you are a commercial credit underwriter with whatever years of experience. So setting up a role instantly, shapes the vocabulary that is going to be used in the output response, the depth and the perspective. I mean, everything changes the moment you ask the model to assume a role. Second thing your prompt must have is exactly the task. The task has to be very crystal clear. There should be no ambiguity. And it is usually a good practice not to have too many tasks in the same prompt. One to two tasks which are very clear, related, is okay. But having too many tasks which are, very varied, quite different tasks, you are asking the model to do too many things at once. That is what you should avoid, frankly, in my opinion. Okay. So specific actions like analyze this document, or analyze this graph, analyze this trend, analyze this, time series data, draft a email, story, marketing campaign, classify the customer inquiry for sentiment, or inquiry category for routing into a specific department, compare different documents. Okay, for, let's say, you have uploaded two different PDFs. Each PDF is like SEC 10K filings for two different companies. Let's say you want to compare their balance sheets, performances across years, and so on. Recommend, you are asking the model to recommend the best framework, solution design for a given application that you have in mind. Okay, so these are action items, what you want to achieve from that model, from that prompt. Exactly, they should be unambiguous and singular. Okay, so some examples are there: analyze this transaction for suspicious activity indicators, or draft an adverse action notice for the denied application, or classify these 50 customer complaints by category, and so on. Right? Context, what additional background information is needed? So for example, uh, let's say if you are asking the model to classify the 50 customer complaints by category, so what are these 50 customer complaints? That will go in the context, and the category names will also go into the context. Okay, If you are asking the model to analyze the transaction for suspicious activity indicator, that transaction itself will go as a context. Okay. So the customer data, account history, market conditions, regulatory requirements, prior decisions, this is the context most accurate output. So some example like customer profile can be given, and based on a customer profile, you can ask the model to suggest the best investment strategy for achieving XYZ goal in the next 5 years based on the amount of risk the customer can take. You can ask for generic suggestions, no doubt. Okay. Or let's say the previous task was to analyze the transaction for suspicious activity. That transaction itself and the prior transaction history, okay, can be provided as a additional context. So current portfolio holdings, if you want the model to analyze the holdings based on the sectors or the percentage holdings across sectors, let's say P/E ratio, maybe, or the dividend yield, or the overall Sharpe ratio of the portfolio, whatever be the metrics. Okay, relevant regulations and so on. Okay. Oh, sorry. Constraint. Now, usually we don't want random outputs from the models. We are looking for specific outputs and specific format of the output. That also you should tell the model if you have in mind. So what should be the output format? Are you looking as a normal string or bullet points? Let's say I want to get the difference between A and B, but not as a paragraph. One paragraph of A, one paragraph for B. No, I want A and B to be differentiated. Let's say I want the model to differentiate chainlit versus streamlit as a desired framework for deploying a customer support chatbot. Okay, fine. So how do you want the differences to be? Should it be as a table or five uh, bullet points for each of chainlet and streamlet? So what is the exact output format and verbosity, tone? So all of these words can be provided in a constraint. Okay. Some guardrails also you can provide. Prohibited content can be provided so that the model should not answer those kind of questions or in that kind of a language and so on. Okay. So these constraints prevent hallucination and also ensure regulatory compliance. So for example, if you are sending out a customer email, okay, the tone will be different. Let's say it could be more friendly, empathetic tone. But if you're writing on a report for compliance, then the tone has to be suitable for regulatory correspondence. Okay, or it must not include specific interest rate promises. Let's say your bank has launched a new fund. Okay, new mutual fund has been launched, and you are sending out an email to all of your customers asking them to, you know, or inviting them rather to make investment in that mutual fund. So this is usual practice that that mail should not have any specific guarantee about the interests and the amount of returns that this mutual fund will provide. Okay, that's again because of the compliance regulatory reasons, right? So it might generate 15%, 18%, but you cannot promise anything more than the regulation. Regulation says 7.5% in India. So anything more than the fixed deposit, you cannot use a number beyond a number which is more than a fixed deposit, or literally avoid that altogether. Or if you want a model to strictly adhere to a specific format. So all of these constraints you should be providing. Let's say you want to learn transformer architecture. Okay, you go to the model and say that I want to learn transformer architecture and give me a plan. Now here the problem is you have not given, so you have given a task, but you have not given a context. What is your current level of understanding? What is your current level of Python programming skills? Okay. Uh, you have not provided any of this background. You are coming from a completely non-tech domain or a technical domain. If you know something about Gemini, this and that. So that context you have not provided. And why are you learning this? Where would you go and apply that knowledge? Okay. In the constraint side, we have not provided the output format, how that plan will look like. Do you want it to be a 6 months plan, or do you want it to be a 6 weeks plan? You have not provided that constraint. So model will keep some assumptions. Based on the assumption, it might give you a 4 week plan or a 6 week plan or a 8 week plan or a 6 months plan. Okay. So, and again, do you want the plan weekly or monthly or a daily? So all these things, the output constraints you should provide. This is a very, very, powerful technique. Instructions. So you have provided the task as a high level that, okay, analyze this transaction. But what are the steps should be taken in that analysis? So that detailed instructions you have to provide the step-by-step methodology for analysis or calculations as per the regulatory compliance. Again, let's say if a credit risk assessor is actually doing that himself. So what are the actual step that guy would be taking? So those things you should provide in the detailed instructions. If you want a model to give some, assessment using reasoning. So what should be the reasoning steps? What are the do's and don'ts? So this is very, very powerful for complex analytical tasks. So for example, here, step one, verify this. Step two, do this. Step three, do this. Step four, do that. And finally, do not recommend account closure without manager's review. I mean, that is exactly the level of detailing you can have in your prompts. Okay. So this RTCCA framework will mostly stick to this, and there are some more examples in this presentation you can see about the instructions and other thing guardrails. You click on these tones, length, and prohibitions, and you'll get more examples of all of it. Okay, so I'm just skipping ahead, and so let's directly go to this lab. It's not lab one, it's actually lab two. This presentation was created for some other audience, but I'm using it because I find everything is already included in one presentation. So just ignore that. Lab 01, this is actually going to be lab two. Fine. So lab two, I have already shared. Okay. Or let's see. Is there any restriction for prompt size? Answer is no. But theoretically, yes. So why no and why yes? No, because it doesn't make sense to have a restriction in the prompt size. And yes, because there is actually. Okay. So we give 5 line prompt to 50 line prompts. Model won't get confused. No. So for each model, there is something called as a context window. We'll talk about the context window in the later part. There is a context engineering. So let me get to that point, and then we'll discuss about the context window also. So you will learn about the constraint there. Okay. Fine. So I ran this. We'll be building everything from zero shot to React, building an insurance claim classifier with progressive prompting one by one. Let's see. Now, usually in my previous cohorts, I used to take separate notebooks for each of these prompting techniques, but now I want to consolidate all of that into a single uh, notebook here. So this will give you a notebook as a ready reference for all of these patterns, I would say. So some fictitious company is there called a Secure Life Insurance, and they are receiving 200 plus health insurance claims daily. Claims intake team manually reads each of these claim description, classifies it by category, urgency, and fraud risk indicators. And for a human, it takes roughly 8 to 10 minutes per claim to understand that claim. And this is at bare minimum. It can go to 15 to 20 minutes as well, depends on the complexity of the claim and the incident. So in this lab, we'll build AI classifier using our increasingly sophisticated prompting techniques. So we'll start with zero shot and we'll see how it can go up to a React prompting technique. I mean, so this will show you how these techniques have evolved, I would say. Okay. So we'll explore context engineering. We'll talk about token budgeting, just-in-time retrieval, and reusable skills, and build a LLM as a judge evaluator also. Okay, fine. So these are the overall topics. I've installed this, and then let me, if you want me to run this, I'll just clear all the outputs. Okay. So my keys are loaded. Okay. Here again, I'm going to use the OpenAI or the Grok model. So if you are going to use the Grok model, make sure you copy that Grok function from the previous notebook. Okay. And change these. So wherever I'm using the call LLM, okay, that call LLM function will change to the call Grok model function. So you have to copy paste. That is one additional effort you will have to do on your own. And I think it's reasonable to assume that you should be able to do if you're really interested. Okay, that will be a good practice for you as well. Okay, so two functions, one for non-reasoning model, which supports temperature, and one for a reasoning model, which supports the reasoning effort. Okay, so otherwise everything is same as in the previous. If you want to use the Grok model, you'll have
Okay.
to import that function which I have created in the previous method. And wherever I'm using the call LLM, change that call LLM to the call Grok function name. That's it. This is good for OpenAI, right? So this is just some data I'm creating, which we'll be using in the subsequent downstream task. Okay. So this has claims based on different types, urgency levels, and fraud risk profiles. These serve as our test data set throughout this lab. And this insurance company processes claims from hospitals and policyholders across India. Each claim arrives as a free text description and must be classified for routing, prioritization, and fraud screening. So all of that is already done, frankly. Um, from a free-form text, we have converted into these JSON formats. So that's a claims database. You can see it's a mix of clean, suspicious, and also there are edge cases. Okay, now it's difficult to manually figure out what is what. This is all created by some ChatGPT model. So let's go ahead and use that. So this is the distribution. So hospitalization claims out of that are 10. So 20 claims I have in my database, let's say. Outpatient is 5, dental is 2, maternity is 2, and critical illness is 1. And low profile and high profile is also there. So some of these guys have already pegged claims in past, or some of their profiles match with people who would have already made some fake claims. So that's why 5 claims have been marked as high risk. Okay, now we'll do a zero shot classification. Zero shot classification means, so before that, again, in this notebook, I have not demonstrated the RTCCI framework as such. If you want that as well, maybe I can share one notebook for your self-reference. Okay, let me do that. I actually didn't want to discuss it formally. I'll just share this and you will do it on your own. Okay, so this is again just to teach you that RTCCA framework, how does it work? Again, let me show you at a high level. I'll not share this right away. I'll share this with the team. I'll have to make some changes, but this all theory is already shared in this, uh, presentation. Importantly, how to actually use that framework that I have given with few examples. So, for example, there is one uh, customer inquiry is there, and for this customer inquiry, so I mean, what I'm trying to say is you should be knowing about this framework even before you jump into the zero shot classification. Okay, this is like after you have a thorough understanding of that framework. So theoretically discussing that these are the 5 components may not be sufficient. You should be actually seeing that in working. So this is the actual lab 1 notebook crafting precise prompt that I will share as a additional learning for your side. Okay, so let me show this. Yeah, bonus you can say. Okay, so what I want to do is, let's say as a loan officer from some bank, you are receiving dozens of customer inquiry emails every day, and you need to have a quick structured summary to assess the eligibility at a glance and prioritize your workload. So let's say there is a big email coming from one of the customers. I want to generate a quick summary so that I can assess whether this customer, you can say, inquiry for the loan is approved or not. Let's say. So what does this Customers say, my name is Michael Thompson. I've been a loyal customer with whatever bank for 8 years. I'm reaching out because I'm interested in applying for a home loan. My wife Sarah and I are looking for buying a house in Austin, Texas. And we have been renting for years and finally feel we are ready to go for the big step. A bit about the financial situation. This guy is a senior software engineer with Dell and annual salary is $145,000. Wife is registered nurse, earning $78,000 per year. Together, household income is $223,000, which is pretty good. Now, they have already got a pre-approved from another lender for up to $550,000, but they would prefer to go with the same bank because they already have got the banking relationship. They already have their accounts with the same bank and so on. So we are looking for properties in this range, roughly $450,000 to $500,000 range. So that is there. So which means probably they are ready with the 50% upfront payment, it seems, right? So they also have about $95,000. Acha, saved for the down payment. So I'm so sorry. So roughly they are going to make 20%. This is going to be roughly 20% of the loan amount sought, which is a good mix, like 80% loan and 20% for the down payment, which is, I think, around 20%. And the credit scores are also there in the email itself, 762 and wife is 748. Only existing debt is the wife's student loan with $28,000 remaining and which is costing $450 per month for with 2 years still left for the repayment. So please know the documents and what would be the next steps. So pretty long email. I'm not running this, but if you execute this, so there is no output, so no point. I think I'll just show you the outputs quickly. Then only it will make sense. Don't worry. I'll execute this at my end and I'll show you. Okay. So the naive prompt which most people do is summarize this email because I don't have time to write down big elaborate prompts. So people are lazy. So summarize this email is a simple prompt I have written. Let's see the kind of summary that we get. Okay, that will be a shorter output, but mostly that will be useless again because you still have to go through that line by line and figure out the numbers and the data points specific to make any decision about whether to grant the loan approval or not and so on, or decision making you can say. Okay, so let's see the output. Okay, so this is the prompt and I'll get the response just below this. So this is the complete response I've got from the model. And this is still useless because it is again going to take almost the same amount of time, okay, for me to go through this. So this response is a general summary, lacks structured information, and key financial metrics are buried in that prose, and it's very difficult. So this is still useless for a loan officer. So what is a refined RCECI framework? Now your role is you are an experienced loan intake analyst for whatever bank, specializing in mortgage pre-qualification assessments. Task: extract and summarize the key information. And context, that entire email I'll paste here as a context. Constraint: provide a structured summary with these sections. I want the applicant overview, loan request, financial profile, key strengths, and preliminary assessment. Okay. And extract only the information explicitly stated in the email, which means do not hallucinate this and that. So these are the constraints. Keep everything under 250 words. Tone should be professional, concise. And these are the further instructions. Okay. And now when I execute this, see the kind of output I get. So this is the response I'm getting. I'm not even expecting a JSON format. JSON format is good for CRMs or if you want to upload that data to a loan application system or loan origination system, something. But if you're looking at for your own personal consumption, then JSON format will be more confusing. Structured output with proper bullet points is more than sufficient. Now I can quickly look. Okay, the name of this guy is Michael. Contact information, relationship is over 8 years. Fantastic. I don't have to read all that prose, right? Type of loan seeking is this much, amount, location. Super. Financial profile, combined monthly income, Okay, down payment is this much, and credit score this much, and this is the pending. Fine, key strengths and pre-approved already, significant savings for the down payment, and preliminary assessment that is coming from the model is initial eligibility impression appears favorable based on financial profile and existing. So now, since this is favorable, I'll reach back to the customer saying that, okay, these are the next steps, how you have to apply, or these are the forms that you have to fill up, provide the details about your um, financials and the property details, this whatever it is, as per the bank's protocol. Okay, but at least this is much more sensible. See, that is the immediate impact of your framework. That's the point. So there are other examples. They are just, again, naive prompt is simply saying there is a declined transaction and you want to generate a SMS notification. Okay, which is clear, reassuring. Um, so there is a declined credit card transaction. Let me give a complete idea. There is a customer debit card transaction of so many dollars at Best Buy was declined due to a suspected fraud by the bank. Now the bank's automated system needs to send a SMS notification, okay, without causing unnecessary panic. So this is the transaction data. Customer name is Jennifer. Amount is $2,847. Merchant name and the decline reason. And card last four digits is 4892. So write a SMS about a declined transaction. This is a naive prompt. Write an SMS, okay, without any framework. Now, with a proper framework, again, you are a customer notification system for whatever bank responsible for generating security related SMS alerts. Or even if you miss this, that's fine. Responsible for generating crisp and clear SMS alerts. Even that is fine. Your task is to draft a SMS notification to inform a customer about a declined debit card transaction. Context, you have to provide all that details from this. Okay, and then constraint and then instructions. You see, so after I execute this, the kind of SMS I get is completely different. So if you go above and see, so hi Jennifer, this is a notification regarding your recent transaction. Unfortunately, it has been declined due to suspicious fraudulent activity. Please check your account for unauthorized transactions. It is too long. It will not even fit in 160 characters. It has completely missed that point, if you see. And contact us if you have any details. I mean, but here it's very clear, crisp and clear immediately. So this bank, hi Jennifer, transaction was declined due to security review. Please call us to verify. As simple as that, without any panic. So it is concise, reassuring, includes all the necessary elements, provides a clear next step that she has to call to verify that transaction. Okay, so customer needs to be informed, not make them alarmed, and they know exactly what to do. Okay, so this notebook, I can share it right away, but I need to make small changes here. If you are okay, I can share it right away, no worry. Okay, so there are two more exercises. I would strongly encourage you to do those exercises on your own. Okay, so I have two exercises for you for practice. So do it. Okay, there are exercise number 1, and similarly there is exercise number 2. Fine. So now that we know this is how RCECI framework works in principle, we are good to discuss the zero shot. Okay. Okay. So what is zero shot? So in zero shot, we have the input prompt. In fact, whatever we have done until now is zero shot. Whatever we did in the previous notebook, let me repeat that. Whatever we did in the previous notebook, those two examples which I showed, those are zero shot. Okay, so what do we mean by zero shot? We are not providing example. Listen to me carefully. We are not providing example of the output, how it should look like. Okay, I'm not demonstrating that your output must be like this or should resemble this. That is the meaning of zero shot. So I'm providing zero examples. If I provide two examples, then it's a two shot prompting. If I provide one example, it's a one shot prompting. If I provide, let's say, 5 examples, then it is multi-shot, or we call it as few shot prompting. So in few shot, I'm providing examples of input output pairs. Okay. I'm providing examples of input output pairs. And if you're providing multiple examples of this is the input, this is the output, this is the input, this is the output. Okay. Input output pairs. You're providing multiple examples. In that case, you don't even have to follow your RCECI framework, because you can still use the role, but all the other 4 things will be learned by the model using this input output pairs. Let me repeat that. If you are providing few examples of input output pairs, that is the case of a few shot prompting, then you don't even have to follow the RCECI framework except for the role part. The other 4 things will be learned by the model on its own from this data, from these examples. So what is the task? Task will be learned by the model looking at the output and the kind of input. So it will do that input output mapping, and based on that input output mapping, the model will try to understand what is the output you are trying to get. But if you mention just in one line, that will be very super helpful. But that's not mandatory, as I said again. Okay. C is the constraint, context. Context is again the input itself. Okay. Constraint, it will see the output and learn the constraints on its own. Instructions, again, it will see the output based on the input prompt again, and it is going to do all sort of reasoning, and again it will understand the instructions on its own. So this is like rewiring the model, or slightly softly retraining the model, okay, to produce an output without providing explicit details of how you want a model to produce that output. So you're not providing detailed task, detailed descriptions of the context, constraints, and the instructions. Model is self-learning all of these, looking at the input output pairs. That's few shot. But if you're not providing the input output pairs, that is zero shot. And that's what we did not do in the previous notebook. We just had a customer email and we wanted to generate the summary, isn't it? Then in the second case, there was a declined transaction, and using the RCECI framework, I asked it to generate a SMS. I did not provide an example of how SMS must look like, correct? So the previous notebook was already zero shot. Let me give one more example of zero shot here, okay? So if I go to zero shot here, okay. So persona pattern we have discussed. I mean, the moment you provide the role, that itself provides the persona pattern. And the flipped persona pattern, it's nothing but you pretend yourself to be one of a specific type of audience. Like you are a beginner in machine learning, you are a beginner in generative AI, or you are a class 10 kid, you are a 10-year-old, or you are a AI ML expert. So you impersonate a specific audience type, and that very moment, the model knows that you are an expert or a naive person or a layman or a kid. And so the tone of the output, the depth, the technical depth of the output will automatically change. That's called as flipped persona. So where do you provide that detail? Just after the role. So there is an example here. So the normal, so ideally you should provide both. So you are a derivative specialist. That is the role that you have provided. Along with the role, ideally you should also provide, explain this to me like I am a first time home buyer, or you will take one of these kind of phrases, right? You will take this as one of these phrases. So a powerful combination is demonstrated here. So you are a senior mortgage officer. That is the role you have set for the model. And then explain the difference between fixed and adjustable rate mortgages to a first time home buyer who has never taken out a home loan before. See this second part, to whom. So if you simply ask the model to explain, it will give you a very, let me go to Grok platform and show you. Okay, go to playground, take whatever model. I'm taking the ATB parameter model. Okay, explain the difference between this and this. Let's see what I get. Reason I like Grok is this is instant, doesn't waste my time. Okay, so I'm getting some technical details, adjustable rate mortgages. Okay, if you have this key differences and so many details. Okay, this is the output that you are getting. Now let me copy the previous prompt completely. Okay, and let's see the kind of output I get now. Okay, it has a lot of details you can see, but let's clear this and see what is the impact of the second part of the statement. So it directly starts with congratulations for considering purchasing your first home as a senior mortgage officer. I would be happy to explain. See, that very instant, the entire language has changed. And it has become very friendly, like a story. When you take out a mortgage, you are essentially borrowing money from the lender to purchase a home. See, the very first statement is explaining you the concept of lending or borrowing, right? See, that is the naive assumption that the model is having, okay, that you probably even don't know what borrowing means from a bank or a lender. In exchange, you promise to make monthly payments. See, the language here so user friendly, okay, which includes both the interest and the principal amount that you are borrowing. And the interest rate on your mortgage determines how much of your monthly payment goes towards each of these part. Now let's talk about two main types of mortgage, fixed and then adjustable, and then it will. So see, no technical jargons here. Very simple language, very simple language. So this is exactly the power of a flipped persona pattern. So if you want to learn something, see, when will I prefer this? Especially when I want to learn something, then you have to make yourself naive. You can't say that teach me like I'm a already AI ML expert. If you are indeed that, and you are looking for an explanation which is really technically deep, which I do normally. Okay, I'm not trying to boast and do uh, procrastination here. But let's say if I'm asking model to explain me logistic regression or decision trees, I'm not asking the model to explain me like a beginner. I'm looking for deep technical insights in such a case. Okay, maybe for some interview or something. Okay, so you have to impersonate, provide the correct context. See, this is a part of the context itself, who you are ultimately, because the task is still the same. Okay, so who you are is actually a part of the context. So in zero shot, I have already mentioned that you don't provide any examples. The model relies on its entire training itself. In few short, you will provide 2 to 5 examples. So I have given a simple example here. Okay, classify the transaction as one of these three: normal, suspicious, or needs review. You okay? This is the entire prompt. This is the entire prompt. Okay, a wire transfer of this much to a new international beneficiary in a high risk jurisdiction initiated 2 days after account opening. You don't need any setups. I mean, no big system prompt, this and that. Model may classify inconsistently across different batches. That is a high possibility. And you don't understand what, or you have not provided enough context of suspicious. So model may just hallucinate suspicious randomly sometimes. Okay. Let's see what I get for this in the Grok Cloud. So clear. And let's see. It is giving me a number of things. Okay, it is giving me a number of things. But the moment I provide these examples, okay, I just copy this. Okay, what I wanted was only the output. What I wanted is only the output. I did not want the, can you see? Only the outputs are being provided as the output. Okay, so this is the input and this is the output. This is the input and this is the output. This is the input and this is the output. Okay, now classify the same. Okay, now let's see what you get. In this case, there are no explanations also, right? I don't want the explanations, but I'm not even mentioning explicitly that nowhere I'm clearly mentioning that don't give me explanations, don't give me those headers and footers. Okay, let me just clear this. So this is giving me explanations also, right? Reasons and all that. I don't want. So the moment I provide those examples, 1, 2, 3, 4, okay, this is correct. And let me submit. Okay. So immediately, now classify this. I'm getting this. But again, it was not supposed to give me the reasons because that was not there in the output. And let me check what went wrong. Okay, let's clear this. Ideally, if the model understood everything properly, could be a formatting problem. Maybe may not be. Let's see. Let me exclude these and retry once again, or else I will change the model and see. Ideally, I am expecting a single word, okay, without reasons. Still the same. Let's take some other Gwen model. Clear. This is a reasoning model. And so the reasoning models are even more difficult to control. Okay. Let's take the instant model, 8B, simplest model. Okay, so I'm getting some output and basically now classify this 2 days after the account opening. So all of these are able to classify this as suspicious. That is one consistent thing happening. Let's see what I get from my code. Okay. So if I want to do that, I'll be able to get this. So, I mean, that is a simple example. So let's take how much time we have? Oh, so we are already short of time. But okay, let's finish with a zero shot. We have already reached this point. Okay, so this is the complete prompt. You can say I'm putting the prompt inside the function itself, this dummy function that I'm creating just to execute that entire prompt. Okay, so this is just a dummy function. Let me repeat this. Okay, so this function is just going to classify the claim using zero shot prompting. So this is the entire prompt template that I'm providing here. Okay, classify this insurance claim. I'm providing the claim description, amount, and the hospital. And I want the model to return a JSON object with these fields. What are the fields? Type, urgency, and the fraud risk. And let's do it for all those 20 cases above. Now here, in some cases, it is able to provide a proper JSON. Some cases, it is not able to provide the proper JSON. And that is the reason it is failing in 3 cases. So this is the problem because we have not provided the proper JSON format in the JSON format is there, but you have just mentioned the field names, but you have not provided the examples of the output. Okay, so it does generate JSON, and when I try to parse that JSON, I'm just loading that. Okay, I'm using this JSON.load function. Okay, so this result is basically I'm pulling that from the model. So this is the result coming from that model. Okay, you are putting that claim as the input, and this is the function which I created above. So the output of that function is going to be mapped to the result, and I'm just loading that result as a JSON file. So if this result is purely JSON and nothing else, the parsing will not fail. Ideally, if this result is purely JSON, nothing else, not a single character before and after the JSON, then this parsing will not fail. Here, it has failed in 3 cases. Okay, and that is a problem. When I do a few shot, you see that I have provided example of the JSON. So JSON 1, JSON 2, JSON 3. I have provided clear examples of the JSON and claim patient. So claim example 1, example 2. I have 3 examples of input output pair. So this is my input, this is the output. This is the input, this is the output, this is the input, and this is the output. I'm providing just input output pairs, nothing else. The only additional line is classify this based on the examples. You see, I've not even mentioned that you have to do uh, classification and provide me as a JSON. See this entire prompt. Okay, the only line that I'm mentioning is you have to return a JSON. Okay, and the format also I have not provided. It is going to learn the JSON format from the outputs. Okay, it has to learn the JSON format from the outputs. Let me run this and see each time that JSON, at least the success rate is higher. Last time when I had run this, it was 100%. So let me just run this once again. Okay, it is failing for one case, but at least 80% chances that this model is producing a JSON consistently. It's for the third case which is failing every time, it seems. Fine, whatever. But at least you can see what is the problem. Acha, okay. So the urgency field is being misclassified. Probably that is the only difference. Otherwise, the JSON format being created is correct. It's only the urgency field is having a different value. So this was supposed to be priority, sorry, supposed to be routine, but was predicted as priority because it's a maternity. So otherwise, the JSON output is very much followed here. Okay.
So yeah, this covers almost everything in Lab 1. You will know how we're going to set up the 4 LLM providers, how we're going to compare them side by side, and how you could extract the structured outputs with Pydantic. So we're just getting started with day 2. Coming up next, we'll go deeper into prompt engineering, RAG, LangChain, and multi-agent systems. We're going to discuss how each lab builds what we just covered. And also, if you want to get deeper into agentic AI, we run a free masterclass regularly. The link will be in the description below, so you could register, join the community, and keep building. Let me just quickly show you what the link to the masterclass is. You just need to memorize one single URL. So what you need to do is just head over, open your browser, head over to the first tab. Let me just zoom in. Yes, you need to type k21academy.com/agentic AI 10 and press enter. So make sure to check out this webinar right here. You could claim your free seat just by clicking on this link. Choose the date and timings which is relevant to you, enter your first name, last name, email address, your WhatsApp number, and also let us know if you want help with your interview call or job preparation. Our team is always there to help you. And also, if you don't want us to reach out to you, you could simply just click on no thanks and just attend the session at your own will. So make sure to click on register and you could attend the class as well. So that was the short URL. You could also find it in the description below. No need to worry. And yeah, if you found this helpful, hit like and drop a comment below. If you want more help with Google Colab or anything like that from the session, just let us know in the comments below and we're going to cover it for you. With this, I'll see you all in the next one.